So thank you for coming today. With the recording piece aside, the program that you're about to take part in is called HPC Shell. The HPC stands for High Performance Computing, and the shell is an environment that's used to issue commands to a computer, and it's also available for some programming, sometimes referred to as scripting. So we're going to provide you an introduction to the shell today within a high performance computing context. So high performance computing context basically means you're logging in remotely to a very big computer that belongs to somebody else somewhere else in the world. Right? And so for the case of Compute Canada, or the Compute Canada Federation that Chris, Camille, and I are here representing, we are employees of the University of Alberta, but we do work, we are members of the Federation, or members of that team. We support these systems, and so we want to support you in your ability to use them. And when you log into the clusters, right, we have a cluster at Simon Fraser University. It's referred to as Cedar. There's one at the University of Waterloo. It's called Graham. There's one at the University of Toronto. It's called Niagara. And there's one at McGill University, and it's called Beluga. When you log into those systems, or when you log into the cloud system as well, the work that Irming's going to be doing over the next couple of days about the cloud, typically when you log into the virtual machines on the cloud, all of these systems, the standard way of interacting with the actual machines themselves is through the shell. And so it's foundational. Because of that, and because we typically, when people sign up for this, they haven't had an experience with the shell before. I'm sure there are exceptions with some of the participants here today, but if there's even one of you who has not really used the shell before, I want you to know up front that I'm going to go quite slowly. I'm going to go very slow for a reason, and the reason is, if this doesn't work, your life is going to be very frustrating in the future. There's an assumption that's too often made that everybody knows how to use this because you're using the high performance computing system. That assumption is, well, repeatedly false. So I will take my time. Please ask the questions as they arise for you. I will try to have frequent breaks, both just to give you time to ask some questions and think about things, but we'll also take some breaks away from our computer where we can have some deeper discussions. I'm going to share a link with you in the chat now. So let's test and make sure that chat works for everyone. So this link is not the correct link. Will not help anyone. Here we go. So I've shared a link in the chat to a document that we will use as kind of a communal notepad for today's session. It's called an Etherpad. If you have ever used a Google Doc or some other collaborative online document editing tool, this is very much like that, but it's less formal. So you all have the ability to control and edit everything. You can delete it. There's less tracking of who did what and so on and so forth. So my request is simply that you play friendly with each other when you're in there. Keep in mind that it's not as robust as a Google Doc or anything like that. So it might disconnect from time to time. You might have to reload it. Shouldn't be a problem because we're not going to be asking you to type large paragraphs in here or anything like that. It'll mostly be a notepad for saving you typing out commands that will be long or complicated. You'll be able to just cut and paste from here, and it'll help move us along a little bit quicker from time to time. In that interface, I'm going to test sharing my screen now. So just give me a moment to do that because I'll need to share it for a terminal. And let's make sure it works for this first. So what you should all see now is a screen share is an image of that URL, that web page that you just logged into. And if that's not the case, it'd be really helpful right now if you flag that directly in the chat. So if you'd say, hey, I can't see it, that would be helpful. What I would like for you to do here is two things. The first is in this top right corner, you can see that there's my name, John Simpson, but you're probably listed as anonymous right now. If you change that to your name, then whatever color comes up will be associated with your name. It can make it a little bit easier to track things if you're asking for help in this document, as you might. So that's the first thing that I ask you to do, is to write your name in that top right corner. The second thing that I'm going to ask you to do is, again, note that we are recording this session. And two, it's a carpentry session, but regardless of Carpentries is an organization that tries to build effective training, particularly for novice users of technology tools. So a lot of the stuff that Chris is doing with you on Python is inspired by the Carpentries. Same with some of the things that Irming's doing in the cloud. They have a code of conduct. It's really, really nice. I'm very hopeful we don't have any difficulties, but if we do, I'll lean back on it. And there's an example. There's a link there here in this document to you from it, or to it for you from here. Yeah. Everything that comes after that I'm scrolling through right now should be in the email that you received from me yesterday. It should just be almost verbatim with a few tense changes because we're talking about today. And very important here is number 4, the lesson plan that we're following. That's the link to it. I helped build that lesson plan a long time ago. Maybe it's almost 2 years ago now. What we're going to do today is derivative of that lesson plan, but does not follow it exactly. The reason is, done a lot of this session since originally creating it. And so things have changed for me that haven't been updated here that hopefully make things easier for you. That said, if you have to leave or there's somebody who wasn't able to join us today, we do have that link available. And you could follow along and get some of your questions answered. Almost everything that's in there I'll cover. There might be a few things that I don't, and there'll be a few things that I'll cover that aren't in there, but the overlap should be pretty close. Very last thing I'm going to ask you to do is a little further down here. I'm going to ask you to choose a username. This is going to be important when we log into the cluster, which we'll do shortly. So again, what you need to know here is that for the purposes of today, you should write your name in. When the next HPC session is run, so this is be run by Camille, it's being run on Thursday. One of the expectations we have is that many of you are going to move from this session into that session. Right? And so we'll take this list and we'll copy it from here and we'll copy it into an Etherpad for Camille so that somebody else comes into that session, they're not going to log in under your username, right? And when you log in on Thursday, if you come back for that session, you're going to have the same environment that you left today, right? So you'll have that kind of flexibility. It should be your space. That said, please note that the usernames and the password for this test server that we're using, they're all the same. So you can log in for on somebody else's user account. It happens from time to time by accident. That's okay. We can easily fix it. But please don't do it on purpose. All it does is ruin somebody else's experience. And if we catch you doing it, I don't know what we'll do, but we'll be very disappointed in you at the very least because you're not being a very nice person. So don't do that. So please choose one of these users and just write your name beside it. If you don't want your full name carried over into Thursday or even displayed today, you can just put an initial beside it or just write taken or something like that. And you'll just have to remember that on your own. So if you do that and you don't remember your username on Thursday, we won't be able to help you probably. And we'll just get you a new user account. So that should be the initial background setup. So given that, and before I move to asking everybody if they have a terminal and talking about terminal windows and how to open them, are we good, logistics-wise? I see that code of conduct may have moved. It's possible. Anything else? Questions people have? Okay. So I'm going to stop sharing my screen here because we have this as a communal document now. And so when I talk about the Etherpad, we should all be able to go there and grab information that we need from it. You should also be able to add content in here as well. So if you would like to take some communal notes, then a little lower down here in the document, a way to turn on line numbers here somehow. There was back in the old one. Anyways, there's a little, says training U of A C3.ca. Well, anything after that, if you want to take some notes. So if there's a place you'd like to write things down for yourself and for others, you can come here and you can write them down here communally. You can also use it for questions. Camille and Chris will be watching it throughout. We're checking back on it from time to time. And so here's my stepson is using the printer. So we're going to wait a moment while that stops. There he is. Sorry. It warms my heart to see you printing out your schoolwork. There you go. Thank you. I might have to print something out later, but I'll wait until you're done. That's okay. That's okay. So we have the Etherpad. I'm going to stop sharing my screen. Next thing we need is a terminal window. In the email that was sent out, there was a request that you spend a little bit of time beforehand making sure that you're able to bring up a terminal window. If you are using Windows, you have some options available. One of the easiest is if you have Windows 10. If you have Windows 10, you should be able to open a tool called the command prompt, and that'll get things done for us as well, right? If you're familiar with PowerShell on Windows, you could use that. If you don't have Windows 10, then you're going to need a separate tool. There's many different options to choose one from. The one that we recommend is in the Etherpad here, and it is a tool called Git. So this is under 2.1 here. It doesn't actually have that, didn't copy the link over. So if I could have Chris or Camille grab the link for the Git SCM, either from the email or directly from the web, and paste it in there for 2.1, that'd be helpful if people need that now or the future. If you're using Mac OS, there's a program called Terminal. It should be, it's installed by default in all the modern Mac systems. And you should be able to open it fairly directly. You can go to your applications, you can bring up your Finder, you can go to applications, and then choose utilities, and then underneath there is a thing called Terminal. The other thing you can do that's easier is Spotlight Search. You can hold Command and press the space bar, and that'll bring up a little search tool in the middle of your screen. If you just start typing Terminal, T-E-R-M-I-N-A-L, it'll come up in the little search results window. You can click it and open it. It'll look like a little black window, little black computer screen. And if you have Linux, this is baked in by default as well. And there's so many different flavors of Linux. I can't really describe where it's going to be for you, but it's probably in one of your top menus. If you're using Ubuntu under something called utilities, you should be able to do a search for a terminal window as well. And it'll likely also be represented by a little icon that looks like a little black computer screen. So first question for you is, can you open this, right? I need you to open a terminal window, because if you can't, we want to get that sorted out right away. So when you have a terminal window open, if you would just write yes or write terminal open in the chat window, that would be great. If you're not having any success with this, it'd be super helpful if you just unmute and ask right away. I'm seeing mostly positives here. Is there any outstanding cases? No reason to be worried about this at all. It happens from time to time. And of course, you are welcome to just follow along and watch too. Usually that's less valuable for you. Okay, I'm not seeing any negatives, so we're going to move on. So what we're going to do now is I'm going to share my terminal window. I'm going to make sure that you can all see it, so the fonts are the right size and so on and so forth. And then for most of the rest of this, I'm going to use the terminal window. What I type should be almost exactly what you're typing. In 99.9% of what we do today, it will be exactly the same. unless you're doing your own exploratory work and doing other things, which is fine. But we should be able to replicate our environments exactly the same. So if you ask a question and say, John, what if this happened? I can say, well, why don't you try it? And you can try it and see what happens. And then I can try it and I can show it to everybody. So that's going to be a very powerful learning tool for us today. It's going to be on a screen just to the side. So if we're talking through video, I'm going to be looking at you. But if we're talking about the terminal, it's because my window's over there. Please don't think I'm checking my email. I promise. I'm here for you for the next 2 hours, 3 hours. Let's do it. If you have Windows 7, you can try it, as Chris is calling out here. So if you have the command prompt on Windows 7, the question is, what happens when you type SSH and press enter in that command prompt? And if it doesn't give you a command not found, or I don't know what the heck you're doing kind of error, then you should be okay. Haven't been able to test it with Windows 7. Or you able to get that, Reza? Okay, well, we'll know if it's working as soon as we do this next step. So if it isn't, please let us know right away and we'll get you sorted out. So I'm going to share my terminal window, make sure that it works well, and then away we go. Okay, so I can't see what you see. I see my terminal window, but I can't see a version of what it looks like for you. So my questions are going to be directed at you. I need some answers, or it's just not going to go super well. Is the font size okay, or would it be helpful to have it be a little bit bigger?
It looks good from my side.
So we've got, it looks good, it looks perfect, okay. It's fine. Wow, this is a big win over doing it in person, right? Where I've got to jump it up to 28-point font so the back of the room can see it. So real nice. Okay, if that changes at any time today, let me know. I can change the color of the font. I can change the color of the background. You can probably do that on your system as well, right? This is the default way that it opens, and I don't want to get into messing around with it too much. So we'll leave it as that. There will be another question I'll ask in a little while to make sure that you can see all the content of my screen, but hopefully that works fine. So welcome to the shell. Welcome to the terminal. So the terminal is the window that you're in, right? It's this space that allows you to have this typing interface to the computer. And the shell is the program that's running inside the bounds of that terminal window. The shell that I'm running on right now is called BASH, B-A-S-H. It stands for the Born Again shell. There's a little bit of programmer humor in there because there was a shell that predated it called the Born shell. And this is a revision on that. It's probably the most popular shell that's available, but certainly it's nothing special about it other than that. And you can see here at the top when my window first opened, when I opened this shell, because it's being run on a Mac OS X system, it's telling me that my default interactive shell is now a different shell called ZSH. I'm not actually I'm not using it right now because I was using the bash shell before. That was the Mac default. They've moved to Z. Anyways, point is when you first log in, you're going to get a bunch of messages, usually about system states or notifications or things that might be important. You'll see those when you log into the Compute Canada clusters as well. There'll be little updates there that'll say things like, oh, by the way, the following files are set to be deleted within the next 30 days or something. You need to pay attention to those and not just ignore them because they just kind of scroll by. So we get some information. It tells me when I last logged in. Are you able to see the highlighting? If I highlight like this, are you able to see highlighting? Thanks, Camille. We get some notifications, and then we have something else down here that's called the prompt. And so the name of my computer is Simpson MB Pro for MacBook Pro. Right? It's an older MacBook. then we have a colon and a little squiggle. And we'll get to what that is in a little bit. And then it tells me what my username is. At this point in time, many of you will probably have different information there. You won't have the same information up top because you're running on a different operating system. And you won't have the same information in the prompt, either because your shell isn't set to provide it by default, like the Mac OS one is, or because you're not using Mac OS, right? We're using a different shell, and that's okay. But you will probably have a $sign and then a space and a little block. Could be a cursor that's flashing. This is the prompt. This is where all the magic happens. So I don't see anybody complaining, so I assume we're this far. First thing I'm going to ask you to do here is get us to the same system. I'm going to ask you to trust me on this, and then once you've done that trust, then I'll go back and explain everything that we're doing and why we did it that way. So let's log in to the remote system. So let me do it first so that you can see it, and then I'm going to give you lots of time to follow along. So first thing I'm going to do is type the command. The command is SSH. It stands for secure shell. It's going to open an encrypted connection to a remote site. Space. Then I'm going to type in what looks, for all intents and purposes, like an email, right? It's got a server address, and then before that server address is an @ sign, and then before that is a username. And my username is user01 @ and so then we need the server address. Well, that server address is the training.uofa.c3.ca that's at the bottom of that list of possible usernames that you can get. So training.uofa.c3.ca. So that's what I'm going to be typing. I'm going to press enter. I'm going to show you how to log in, and then I'll give you time to do it. I'm sure some of you are already gone ahead, but here we go. Couldn't resolve the host name, right? It's not there. What did I do wrong? You can just unmute and tell me what I did wrong, or you can type it in the chat.
Is it the spelling of training?
Oh, absolutely. Ah, look at that. Spelling counts, darn it. All right, that was not intentional, but something that happens from time to time, right? Particularly when you're touch typing. So training, right, .uofa.c3.ca. Now, I did something really sneaky there. Did you see how fast I was able to type that again and correct it? So I wasn't even thinking of it because I'm used to doing it. But for you, it probably looked a little bit like a miracle or just a blip in the video that we're used to seeing these things from time to time. But if you were to do something like this, you can press up on your keyboard and you can recall the set of commands that you've already typed in. So that's what I did to bring it back up, and then I just cursored over to fix it. If I press enter now, it's going to ask me for a password. So the password, we're going to put in the Etherpad here, so there's no question about what it is. So you can just copy and paste it. I'm going to put it right under training.uofa.c3.
Hey, John?
Yep.
Please don't put it in the Etherpad.
I was just going to put it there for like 30 seconds, Chris.
Okay.
Is that all right?
I'd prefer it in the chat, but if you have to do it,
no,
do
chat's
it,
fine, chat's fine, chat's fine, chat's fine.
Just that it's a publicly accessible document, and if they see
Yeah, I got it, I got it.
and stranger on the internet sees it, then
Oh, sorry. And it's lowercase, right?
That's right, yeah.
So, oh, I'm getting auto-corrected here. That's what's happening. So here's the password. Lowercase, Bigfoot, B-I-G-F-O-T .369. Now, watch what happens when I type it here. Do you see anything? Does anybody see my cursor? Do you see any stars or anything going across? The answer is no. Right? And this can sometimes be disconcerting, right? It's like, well, what's happened here? Particularly if you're typing and you think you made a mistake and you don't know where you are and so on and so forth. This is a feature, right? This is meant to increase the security, because if you have little asterisks or dots coming up as you're typing, then people could look over your shoulder, may not know what they're typing, but now they know how long your password is. So I'm going to type that in. You're not going to see anything typed in whatever. You just have to trust that every key press actually entered the character you want, and it might take you a time or two to get it, or you can copy and paste it from the chat. I'm gonna press enter, and apparently I did it wrong, right? Because this happens. So let's fix that. Here. Oh, now it was unhappy because I don't know if I typed it in wrong twice or I put it in wrong. Let's try again. Okay. So apparently I typed it in wrong, or maybe the server connection got reset. But it's important you see that from time to time, right? Because you will possibly get booted out at some point today. And you'll see a message like this: connection closed. Section that showed up. Could say something like broken pipe, which means that the connection between here and there was interrupted, blah, blah, blah. So once I log in, I now see some information. It tells me that there was some failed login information. Right, when was the last official login? And now something has changed down here. The prompt has changed.
Just John, one thing. If the users, if you guys are logging in and you guys get asked a question, that question will be, do you trust this machine, basically?
That's a good point. Thank you, Camille. So what's happening there is the very first time you log into a remote system, it doesn't know, your machine doesn't know that this is the right place to be, right? It doesn't have the right keys / fingerprints / identifiers to line up. And so it's going to say, do you really trust this right now? What it's really asking is, do you really trust me? Because if it was really important, those identifiers are stored elsewhere that you can go independently get, and you can compare them to the ones that are being presented here and be like, actually, it looks like I'm being rerouted to somebody else's system. This is not a good place to do my banking or something, right? Here, you should be able to say yes. You should be able to trust that this is gonna work just fine. And you'll probably have to actually type YES. I don't remember if you can get away with just Y. You won't see that here for me because I already did it last night. And I didn't log in with a new account tonight, this morning. So you should all be in. Notice, oh, Rez is still trying to log in. So what's the trouble that you're having here? This is our last check to make sure that everything is coming along here. So once you're in, if you could just say logged in, if you'd put that in the chat, that'd be really helpful. And if you're not, if you could tell us where you're going wrong a little bit, that'd be helpful. It's just deciding for some of you that it does trust you, and that's okay.
Yeah. So somebody says it actually doesn't ask me if it's trusty or not. Maybe you've taken one of our courses before. If you have, then you might have logged into this machine before.
So I don't know, it just says like warning, remote host identification has changed, and it is possible that someone is doing something nasty. So
have you done training with us before?
Yes.
Yeah, that's why.
Okay.
So when the server, the server gets built, and then when we're done training, we take it down. And when it gets recreated again, it's going to get a new set of keys or codes. And so, yeah, the address is still the same. And imagine it's like going to somebody's house and you just destroyed the house, and then you built a new house at the same address that looks exactly like the old house, but when you knock on the door, the person inside isn't who you expect.
Okay.
Right? They've got a different passcode number. And so that's what your system is saying.
Okay.
So are you able to say something like ignore this or whatever? Is that an option for you on your screen?
No, it doesn't tell me anything. It's just, I tried twice and
yeah, I see it.
Yeah, just host key verification failed, and then it gives me again the opportunity to type, but yeah.
Yeah.
I can
So
share my
basi-
screen briefly. Oh, it's
so
okay. Yeah, go ahead. Sorry.
basically, man in the middle means that some other computers could be pretending to be the computer that you're trying to get a hold of, right?
I can just follow. That's fine. I mean, it's not a big
No,
problem.
we're gonna solve this problem for you right now because it's
And
gonna
notice,
happen at some point.
Reza, that you have users 01 instead of user 01 in that
And-
command you typed.
I typed the user 08, like the one that's mine.
Okay,
Yeah,
but
zero.
what you copy and
And-
paste says user 01 instead of user 01.
And I'm user 01.
I'm user 08. Yeah.
Oh yeah,
Okay.
so user 08 isn't working and it's not an O instead of a 0?
No.
I'm worried if we have some inception happening here as well, given that the command here that I'm seeing in the chat is user 01 at login 1 tilde, which is the inside the training cluster login. And then the command being issued is try an attempt to SSH to itself, right? With a mistaken user 01. It's almost as if you're pre-logged in there. So you're going to have some difficulty with that. And that's a thing that can happen. Camille will tell you about it when he has to log into a remote system so that you can log in from that entry way in that remote system to another subsection of that system. And then sometimes you might need to log into another section of that system elsewhere. And the only thing that changes here is this login prompt stuff. And sometimes it's not a significant change. It can be really easy to lose yourself. So if you've seen the movie Inception, this idea of falling back into different thoughts and different states of mind, that can happen here. So
okay.
when that happens, you got two options. You can just keep typing exit until you're out.
Okay.
But then you have to track how far, because if you get to the top level and you say exit, it'll kick you out of the whole thing. So if you know you're in 3 levels deep, you can just exit twice. But if you don't, you can just close your terminal and you can start again.
Oh, okay.
I'm going to show, you. So who was it that was having yeah. So you can just close the terminal window. If you're having problems of the sort we're talking about, you can close your terminal and you can just try again. You should no worry about that whatsoever. Close it, reopen it.
Okay.
Now somebody else had the key that was already being used. Who was that? Somebody got rejected. Yeah.
It said man in the middle. Who was that?
This is Vladimir, I think.
Yeah. Oh, sorry.
Yes.
It's me. Okay.
Yeah. So for you, this is what's going to need to happen. So open up your terminal window.
Okay.
Okay. And I'm going to, for everybody else, I'm going to show you how to fix this problem. You're going to have to follow along. So don't worry about the exit. I'm just going to go back to my local machine. So I'm going to say exit. You're going to see it says log out. Connection to training is closed, and now I'm back at my original prompt. So that tells me that I'm home. Okay. There's a file on your computer. It's a hidden file. You don't know about it until I'm going to tell you about it right now. And you're going to need to go in and edit it to take away the reference to this training cluster that existed before, right? Because until we remove it, every time you try to log in, your system is going to look at it and say, wait a minute, the address says this, but the person who lives there, that's not who lives there. I'm not making this connection. So I'm going to show you how to get rid of that. Once we do that for you, we'll be able to move on with the whole thing. So the rest of you should watch this because it's going to happen to you at some point in your lives if you're going to be logging into remote servers. They do change from time to time. So first thing so this is stuff that you're going to see when we start walking through, but I'm just going to ask you to trust me here for a little bit. I'm not going to explain it as fully, so we can move on. So we're going to use a tool called Nano, nano. It's a shell-based text editor. So that's the first part of the command. I'm going to put a space in. Then there's a subdirectory here called .ssh. The dot.
Sorry, John. Vladimir, are you using Windows, Mac, or Linux?
I'm using Windows 10.
I think it's still here. I could be wrong.
Okay.
I could be wrong. We'll find out in just a moment. Oh, I'm not sure if you have nano. It's going to hurt me here. Okay, type nano.
Okay.
Actually, let's not even do that. Let's see if you have the, you're in Windows on, what's your shell? Shell. You're using the command prompt?
Yes. I have also Ubuntu. I don't know if can make a difference. I installed it.
Yeah.
Linux. I don't know. I can try that one.
If you have that, yeah, that's going to make that easier. But we're going to want to clean this up for you in the long term.
Okay.
Problem is, I'm not sure where Windows stores this list of known hosts. That's a good point, Camille. Thank you. So if you can swap over and bring up the terminal in Ubuntu, and then we will follow up after to make sure we can fix this for you.
Okay.
Vladimir, are you using Windows 10 or 7? Which version of Windows?
Windows 10. Okay, now I have Ubuntu.
Okay, can you open a terminal in Ubuntu?
Yeah. I mean, it's the application, like Windows Terminal in Windows.
That's
Sorry,
fine.
but it's Ubuntu. Yeah, it's kind of.
Yeah, that's fine. That's fine.
Yeah.
We'll try it. It might pull from a different known hosts file. It may not. I don't know exactly how the integration happened on Windows 10.
Shall I just try?
Yep. Yep.
Okay. That looks good.
Okay. So it let you log in?
It just asked me, are you sure you want to continue connecting?
You said yes.
Yes. Or just have to type yes.
Perfect.
Okay, permanently added training
list
view
of known
of
hosts.
yeah.
Perfect. Perfect. So
Okay,
that's
now
great.
it's asking for the password. Yeah, okay.
Yeah, perfect. So stick the password in, you should be all right. So I'm going to log back in. And so for those of you who are watching the terminal screen, again, I'm just able to press up with my up key on my keyboard, and it brings back that login. I don't have to type the whole thing again. It's really helpful. It's going to ask me for the password, which I'm going to type in again, and it's not going to show it to me when I type it in. It's going to tell me when I last logged in, which wasn't that long ago. And it should now be the case that we have everybody. Anybody else? Any other difficulties here?
So the password is Bigfoot.369.
.369.
Okay, thank you.
All lowercase. Okay. Okay. Last call. Any difficulties from anyone? Okay. So it should be the case that you're all logged in. And you should all have something, a little command prompt that looks very similar to this. The only difference for you is that it should say your username. So I'm user 01, somebody else is user 07, somebody else is user 13, and we shouldn't have anybody who has the same username. And we're tracking that in the Etherpad, because if you have the same username, you can both log in at the same time as the same person. It's going to let you do that. But then when one of you's doing one thing, the other one will wonder why weird things have happened around. It's almost like you would have two people living in the same house, but they couldn't see each other. So you'd come into a room and wonder why all the furniture was moved around, and then you'd move it back and the other person would wonder why the furniture was moved around. So that's why we want to avoid this. So let's start looking into the shell a little bit more and how it works. So remember when I was talking about this inception problem where you can end up deeply buried in this set of logins from logins from logins? I'll show you a tool that is helpful for figuring out who you are and where you're logged into. And it's also a good way to think about how the shell works. So I'm going to type a command called who am I. There's no spaces there, W-H-O-A-M-I. And I'm going to press enter. And it's going to tell me who I am. And you might be thinking, well, John, it tells me in the prompt who I am. And I'll say, well, yeah, that's true, but not every prompt on every system is going to tell you who you are, right? And so this command was written to help you remember. Or back in the old days, if somebody left their computer open and you wanted to know who left it logged in, you could ask the system and it would tell you who was logged in. And so who am I is a way for doing that. So how does this work? Well, let's explore how this works by asking the computer another question, right? So let's ask it, where am I? Now don't press enter here yet. Don't press enter here yet. I'm interested to hear what you think you might get from typing this command and pressing enter, given what you got from who am I. So you can just unmute and pitch in here. Or you can type it in the chat. I'd rather hear your voices though. What do you think where am I might do? What are some reasonable guesses? Yeah, it might say traininguofa.c3.ca. Absolutely. Right. Tell us something about the cloud that we're in. What else might it tell us? It'll give you an error. What are some creepy things it might do? Where am I? What would make you raise your eyebrows and feel really nervous? Yeah, it could give you your street address, right? There's systems where that would be true. What's another address that you have in the computing world? What might it give you? Yeah, could give you a GPS location. Chris has got that. It's also, yeah, an IP address. That's another possibility, right? So these are all things that are possible with the command, where am I? So I'm going to press enter. You're welcome to type it in and run it as well, right? What we see is we get an error, right? We get the command not found. So what is going on here? There's two things that I want to draw your attention to. One has to do with the historical development of the shell and Linux and Unix in general. And the other has to do with how the system actually interprets things that are put on the command line. So let's start there. When you type something into the command line, the very first thing that the shell is going to do is take the first string of characters up until the first space, and it's going to say, this is a command. I think this is a command. Okay, well, then what? What do you do with that command? So it's going to take that string of characters, and the first string was W-H-O-A-M-I, who am I, and it's going to go to a list. That list is called the path, P-A-T-H, and every system is going to have something like this. It's a set of directories or folders that the system knows to look in to see if there are any programs in there. Programs that have the same name as that string of characters, or that have what's sometimes referred to as an alias, right? That there's something that says that string of characters, but it's actually this thing over there. So it's going to go looking through that path, through that set of files and folders for a program. And in the first case, it found one. It found a program called Who Am I that then returns the username, the logged in username. When it did for the second one, is it went to find a string of characters that says, where am I, through that same path and couldn't find it. And so it comes back and it says command not found. So command not found means that one of two things is the case. Well, certainly I couldn't find it in that says a pass. So one of two things has happened. Either I typed it in wrong, or it's not in the path. And what's the problem that we'll overcome a little bit later, right? How do we execute programs that are not necessarily in the path? So that's what's happening in the background. You're going to type something, it's going to go try and execute it, and it's going to give you, it's going to return to the prompt again. Command and execute, command and execute, command and execute. It's this constant return of information to you. The second thing is, well, why don't we have where am I, right? Who am I would be is really nice, makes a lot of sense. Sensible command. Why don't we have where am I? Well, we don't have where am I because of how the systems were built. And they were built very, very fast by people that were trying to get things that worked, right? I'll set aside the little bit of the history lesson here. But the bottom line is there wasn't any overarching control over naming structure for commands, how those commands necessarily worked. And there's competing commands that often do very similar things, except in cases like who am I? Like, I don't know who's going to write another command that's going to do something different. The command that we probably want isn't called where am I because of this history. It's called PWD, right? PWD, right? It stands for print working directory, right? And it tells me when I run it that on this system, I am in a file folder called /home/user01. So I'm 3 levels in. It looks like I'm only 2 levels in, but you need to understand that that first slash is called the root directory. That's the very base of the system because you're now on a Linux-based system, right? And everything starts from the root directory, right? And all the other files and folders branch out from there. So there's a folder inside the root directory called home. Home is the second level. And then there's a folder inside home called user01. So root, home, user01. We're 3 levels in. All the other things that you typed in the chat, there are commands that can do things like that. It's harder to get a GPS location, but not impossible, right? There are ways that you can get your IP address and so on and so forth, but we're not going to worry about those. So what you need to take away from this is that when you're typing commands, it's going to go through this list and it's going to try and find them. And if it can't find them, it's going to tell you. It's either wrong or it's not in the list. You've either typed it wrong or it's not in the list, right? Typing it wrong, you can fix. If it's not in the list, we'll show you how to handle one of the ways to handle that a little bit later. And one of the reasons that people aren't happy with the command line and using it is that they have to start learning this specialized language, right? Who am I seems to make sense. Where am I would make a lot of sense, but that's not what was written in here. PWD is the command for print working directory, and you need to know that. So that's a base of knowledge that needs to be built up. So I'm going to walk you through that. You'll notice that we spent about 50 minutes so far, and I've only really shown you like 3 commands. Part of that's intentional. Part of it is we just had some hiccups, but we're meant to go slow here so you understand. So we know where we are. We're in /home/user01. So let's look around. The command for looking around, and these are great things to be writing in the Etherpad if you want to take some communal notes. There's somebody's put in a commands we have used piece, so you've seen SSH so far. I'll let you write in the other ones if you want to take some notes there. The command for seeing the contents of the folder that we're in right now is ls. I like to think of it as kind of the list structure command. And I have to apologize because I thought I cleaned this up last night and I did not clean this up. I got a bunch of stuff in there that should not be there and it does not reflect your environment. You should see 2 things. You should see a thing called projects and a thing called Scratch, right? And they're both folders of different types and they're what you would see if you logged in for the first time on one of the Compute Canada Federation clusters. Projects is a place where you can store your work on a longer term basis, and Scratch is a shared communal folder. It's almost like a giant whiteboard that you can write stuff on. And as long as you're using that stuff, it'll stay there. But if you're not using it, then after so many days, they'll come along and they'll clean it off so that somebody else can use it. It's a great place to put a lot of stuff that you're working with, and then you move it over into project to keep it safe, because that's the essential stuff that you need. So that's why those two things are there for you. The rest of these files and folders are things that you're about to create. You haven't seen them yet. Well, you don't have them because we haven't pulled them down yet. So I'm going to show you how to get these things. Right? I'm going to show you how to get these things. But the first thing I'm going to do is I'm going to clean this up so that this is not something I expect you to do because you don't have these files. You'll see the cleanup again later, but maybe it's good for you to see it right now. I apologize for this. So I'm going to get rid of, I'm going to use RM. This is the remove command. I'm going to get rid of the dmel files, right? I'm going to use the star command to get rid of anything that starts with DMEL, and then the star says anything that comes after that. So I'll get rid of 2 of them. There's a thing called gene, and I don't want to type the whole thing, so I'm just going to put star in there as well. There's a bunch of things called HPC that shouldn't be here, so I'm going to get rid of those. Notice the spaces between these. I'm going to get rid of a thing called my stuff. And I'm going to get rid of that 3F thing. So I ran this, I pressed enter, and what happened? Did it do it? Vladimir is nodding his head, but how do we know it did it, right?
Because it didn't give any error.
It didn't give an error, right? So we know it did something. It wasn't unhappy with the syntax, and we didn't get an error back. The principle you're seeing here is called silence is golden, and it's roughly this. If I ask you to do something, if I ask you, the system, to do something, the system will just go and do it. And unless that doing thing explicitly asks for information back, it's not going to give you that information back. So it's just going to look like it's done. But you probably want to check, right? Just trust but verify. So how do we see the contents of the directory where we are? What's the command for that? ls. Thank you, Cerise. Yeah, absolutely. Right. And so if I run that again, I can see that I'm in a much better spot, right? So I got rid of almost everything. You only have projects in Scratch, correct? Right. So there's 2 other things I got to get rid of, right? So I've got to get rid of extract, and I want to get rid of fastq. So I'll get rid of those in a moment. We're going to go on break now. We're pretty much exactly where we normally end up when we run this workshop, right? So we've dealt with all the logins, we've got all the background on the shell handled, and we're just about to pull down a big block of data. When we pull down that big block of data, we're going to open it up and we're going to do some exploring inside. That's how we're going to spend probably the next block of about 45, 50 minutes. And then once we've done some of that exploring inside, we're going to take another break, and then we'll come back and we're going to build a little script that's going to do some work with some of that data. And then we'll take some questions and we'll be done. So we're going to take a little break right now. I'm going to finish cleaning up this directory while we do it. So why don't you come back at 5 after? So come back at 2:05. So they'll give you just shy of 10 minutes, and we'll see you then. And this will all be cleaned up and it'll look exactly like your folder does. And yeah, and away we go from there. If you have questions that have come up that you haven't felt the chance to ask, this is a great time to do it. I'll be here throughout. So will Camille, so will Chris. Okay. So it should be the case. It's 5 after now, so I'd like to start again. Hopefully everyone is back. We've made some changes to how we're displaying my screen, in part to address Abdullah's question, which the window was hiding, the bottom of the window was being hidden behind the zoom bar. So I'm going to show you another thing that can be done because sometimes the bottom of the screen does get to be a problem. And so I'm going to type a command in the window here. It's clear. I'm going to press enter. What it does is it looks like it wipes the screen clean. Just use my mouse here, and if you have a scroll wheel, you can do this. You can just kind of, I'm using 2 fingers on my trackpad. You can see what it really did was it took everything that was there and it just pushed it off the top of the screen. So if you ever need a clear workspace, you can type clear and it will shove everything up to the top again. It's something that we use a lot in the face-to-face sessions because as the screen comes down low enough, then people's heads get in the way. I wasn't thinking that the zoom bar would get in the way here, but it was. So we've done 2 things. So I'll continue to use clear throughout the rest of this to help clear the space. But we've also changed to sharing my entire screen rather than the whole window. So that should give you a little space at the bottom of the screen to help you do things. So let's get some files. It's time to do that because we need to do some work. So we're going to use a command called wget. And it stands for web get, right? You can go to the web and you can get things and you can pull information down. As you've seen with SSH, it wasn't pointed out at the time, but you've seen it already, commands often have multiple parts. The first part is the command itself, right? So SSH, secure shell, PWD, print working directory, who am I, right? So here the command itself is wget, and then afterwards it has some inputs. Right? And the input that we're going to give it here is a URL. So I'm going to type it out here and then I'm going to copy and paste it into the Etherpad. So you're welcome to type it out yourself if you want some finger practice or if you want to copy and paste it, that's fine too. So we're going to go to a web address. So we're going to give it a URL, https, right, ://. We're going to go to a place called git.io, and there we're going to get a file called HPC shell files.tar.gz, right? So I'm going to copy this into the chat, not into the chat, into the Etherpad, so it's easy for you to grab. Let's come down here. I'm going to paste it just under the training.uofa.c3.ca piece. And there it is for you. You should be able to copy and paste it from that directly. So I'm going to run that. Fingers crossed it works, right? And you get a whole lot of information about what's happening here. So that web address that I put in there is actually a sneaky little redirect. It points to a much longer URL that's really hard to type, and it's annoying to cut and paste. People forget piece of it all the time. So I used a service on the web to get a shorter URL that points to it. So you see a bunch of that bumping around on the top. In particular here, you see it finally resolves what the actual URL is. Right, so that's in this line, then it goes and finds it and it gets it and it brings it down, right? You saw a little progress bar that was happening here as it was filling up to 100%. And we can see that the file it brought down is about almost 12 megabytes, right? So not very big, but it'll be lots for us to work with. And it confirms for us at the end that things were saved. So it told us that, but we want to check it. How do I check and see what's where I am? How do I check? How do I see what files are around where we are? What's the command? Somebody type it in chat. ls, thank you, Pablo. Absolutely. So I'm going to do ls, and we see that we have a new file here called hpc shell files.tar.gz. A note on the coloring, right? This shell and the default settings within this shell are coloring the files to try and help you out. A lot of shells do not do that by default, right? So red things, these are zip files, right? Blue things are meant to be directories. Scratch isn't coming up as a directory because it's or blue because it's a different kind of directory. So you'll have to learn those on the different systems that you're in. So we have a zip file, right? What is a zip file usually? Like, have you used them in the past? Why would we have them? So let me just throw it in the chat. What would you expect might be in something like that? Yeah, it's compressed, right? Makes it a lot easier for transfer, particularly if you have a lot of data. You don't want to send massive bloated data. It's just going to slow you down, and in some cases, it might cost you more money. So we want the compression piece for it as well. What's the other reason that we do this? Oh yeah, avoid some antivirus detection. Sure, wasn't thinking about that one. How many files do you think are in this file? Packaged together, absolutely. So what you're seeing called out here in the extensions at the end of this file are those two steps. The GZ is the zip portion, right? So that's the zip piece. The tar is the bundling. So there were a set of files that were first tarred together. You can imagine having some tar and taking things and sticking them in them to make them one thing, a group that you can combine multiple files with, package them together, exactly as you're saying. And then once we have that, then we compress it. So what we want to do is we want to decompress it and pull the files out of that tar ball, right? So we want to untar it. So we're going to use the tar command to do that. And at that same time, we're going to move it automatically into a different folder. And so we're going to do that in a single step. So the command to tar and untar things is tar. Now I've talked to you about different parts in a command. The first part is the command itself, and then we talked about some inputs. Well, sometimes there are some very special inputs, and these special inputs are called flags, right? And they're little switches that you can turn on or off to make the command behave a little bit differently. And so there's a number of different ways that flags are passed. A very common way is with a dash, right? And then listing a set of letters that point to, that are substitutes for a much larger command. And so we're going to say X for extract, V for verbose. Camille, I'm forgetting what the F is for in the tar. Can you remind me?
It's for the file that you're working on.
Yeah, so with this
so you have to follow that. So you have to follow that with the file name.
Yes. So I want to extract verbosely. Verbosely means it's going to give me lots of information about it. And then F says, here's the file name after, right? So what am I going to untar? I'm going to untar HPC. Now watch this. Watch this very carefully. See how fast I typed that? Right? Cheating here. I'm going to delete that. I want you to type up to this again. I want you to type tar space dash XVF, put a space in. I want you to type just the HP and then press the tab key. What's happening here? Why is it doing this? How does it know what to type?
Because there is the only file that starts with HP.
Yeah.
And then when we press tab, it's going to complete the rest of the name. If there are multiple files that start with HP, we'll give probably the list.
That's right.
Oh, okay.
That's right. So Cerise and Gonzalo, absolutely right as well, right? It's autocomplete like a word processor. And the way that it's doing that autocomplete is it's looking in the immediate folder and looking for things that start with that, right? So nothing else, as you're pointing out, Vladimir, starts with HP. So it makes it really easy. This is a really powerful way to do two things for you. One, let you type a whole lot faster. And two, make sure that you're accurate with what you type, right? Because it'd be really easy for me to, as you've already seen me make the mistake before, and then typing in the server name, I spelled training wrong, to put the wrong thing in here. And if I put the wrong thing in here, right, it's going to tell me it's got an error. And I'm like, oh, then I got to go back and I got to type it again. But fortunately, I know how to get out of that problem. I'm going to press up, right? It's going to bring me the thing back. Oh, I forgot the E in files. So let's put it in, and I'm going to press enter. And it would extract it for me, right? Has anybody already pressed enter and extracted this? If you have, I need you to say so. If you haven't, that'd be great. No, I'm not seeing any yeses. Okay, perfect. Thank you very much for being patient, because I want to do one last thing here. If we extracted it right now, where's it going to put all the files? Right. It's going to put all the files in this directory. And chances are that's not where you want them. You probably want a separate file folder someplace else. So what we want to do is we want to pass it one more flag, right? It's a capital C flag. And it's going to tell us where we're going to put things. I don't know what the C stands for, but it is the flag for working with tar and telling it what folder to put things in. If you already extracted it, that's fine. You'll just have little extra files kicking around, so don't worry about it. So -C, and what do we want to call this folder? Let's just call it extract. Right? We'll just make a folder called extract. Now, I get an error. Right? What's the error? No, I don't have to unzip it first. I'm going to do everything in a single step here. Extract is not a function.
Do we need to create a folder, or?
That's the problem. Yeah, so we see that right here. It's the first thing it tells me when it's upset. It says tar, extract, cannot open this, right? No such file or directory, right? This is not recoverable. I'm going to exit now. So we need to make the folder first, right? So you'll see this again and again, and this is a common problem. You want to put something somewhere, it's going to be like, you didn't make the folder, and you'll be like, oh, I should have made the folder first. Eventually you'll get to that point. So let's make the folder. And the command for that is mkdir. What do you think mkdir stands for?
Make directory.
Yeah, make the directory, absolutely. So we're going to make dir, and then we'll just give it the name. We're going to say extract, right? So this is the folder that we're going to use to put anything that we extract in, maybe. That's what we're going to use it for today. And if I press enter, did it do it? How do I check? Yeah, absolutely. ls. So point here is you're starting to see this cycle, right? You're going to do something, you're going to check it. You're going to do something, you're going to check it. You're going to do this again and again, right? And so you'll see what happened in here. I got a mess, right? It's probably going to look a whole lot like Nicholas's, who went and he'd extracted stuff. What happened here? Well, it couldn't put the stuff in the folder, so it just dumped it all right here. So we're making a mess, and we might come back and clean it up a little bit. But one thing that you should notice that we now have here in blue, because of the defaults for this shell, a folder called extract. Right? So if I press up to come back to the tar extraction command, right, with the -C space extract at the end, and I press enter, right, we see it behave a little bit better here, right? It's not angry. It gives us a list of each of the things that it's extracting. Right? Didn't tell us it was overwriting anything, and so on and so forth. So my hope is that they're all inside the extract folder. So let's look in there real quick and make sure that what we want is in there. And if it's not, then we'll have to fix it. And if it is, then let's do a remove, right? A remove functions like you just saw me do before break, so you can see how to clean up your directories a little bit, okay? And then we'll go into the folder, we'll look at the files, we'll figure out what's in there. and that'll set us up for doing a little bit of scripting work after the next break. So how do we see what's where we are? How do we see what's around us? It's the ls command, right? I've asked you about this again and again and again. It's essential. You need to know that command. So you know that commands can have two parts. So ls on its own shows me where I am by default. But what if I want to see the contents of a directory that's a child of the one that I'm in? How do I see the contents of the extract folder? When you think you've got it, boom, there it is. So let's give that a try. ls extract. And it will show us the contents of the extract folder. So we know that the files are in there, right? So let's clean up the ones in our home directory by using rm. So I'm going to do an ls just to see everything that's in this home directory that I'm in right now. What's the command to remove things? To delete them? It's rm, absolutely. So rm, right? So there's a couple of ways that we can rm things, right? We can rm them one at a time, right? Or we can rm them in a line. And you saw me do it in a line earlier. I'm going to do one directly here. So let's say I want to get rid of gene association. How do I save myself from typing all of gene association? Tab, that's right. Tab completion, right? So I could do it this way. And if I do an ls again, you know, it's gone. It's not in that list anymore. It was here, but now it's gone. It's removed. The other thing I could do, what if I want to get rid of all the SRRs? How do I get rid of them all at once? Yeah, with a star, absolutely. SRR star, right? And if I do an ls again, you see they're all gone. So your task, clean up the rest of this. The only things that you should have left, you should have 4 things remaining. You should have the extract folder. You should have the original zip file. You never want to get rid of your original data. And don't try and delete projects or scratch because it's not going to work for you. It's going to go poorly. So you want to still get rid of the 2 DMLs, right? When you've done that, let me know in the chat window that you're done. One thing that we meant to check when we came back from break, it looks like 2 people are logged in as user 01. If you're logged in as user 01, that's okay if you're just going to watch me do things. But if you want to do things, it's going to be a problem for you. I'm going to make a mess. And maybe what happened is that somebody extracted stuff in the folder I was in. So is there anybody who has user 01 off to the side in their login prompt other than me? Yes. Okay. So we have one that does. Is there anybody else that does? Going once, going twice. Okay. So let's make this super easy. Watch this. I'm going to leave. I'm just going to leave user 01. I'm going to grab one of the unused users and I'm going to catch us back up to where we are. And that'll save us some time and you can just stay where we are. So I'm going to type exit to get out. I'm just going to press up. So I get back my SSH command. And instead of user 01, let's find one. Let's find one.
User 9.
User 909. Thank you, Camille. User 09. Using a window here. Okay. User 09. Okay. What did you get? Pull this down again, and then tar. Oh, what do I have to do first? I need the directory, right? Okay, dir extract. I will tar HPC shell files. I do an ls into extract. Everything's there. So you should be caught up. So question, is it possible to move the unzipped files from the general directory to the extract directory we have created with MV perhaps? The answer is yes, absolutely. And we'll come to do an MV in a moment. But if you already have a bunch of stuff in the extract directory, great. If you didn't, just do the tar thing so you have an example of that working. So it should be the case that for most of us, that if we do an ls, we just see these 4 things in here. And we'll move in there in just a second. Question in the chat. What happens if you put a browser name like UAlberta instead of this file folder? It will go and it will get you the content of whatever it is on the web. So that web page, it'll pull down all the HTML for you. Yeah. So it'll pull that down. So here we are. What we want to do is go inside the extract folder, right, where our content is. It's going to make it easier for us to work with. So the command for doing that is cd, right? It stands for change directory. Right? And again, watch me use tab completion here. I'm not going to type out extract. I'm just going to type the first 2 letters because that's easy to do, and then press tab. Puts in extract. You don't need to have that slash there, but it will add it in full because that's the full reference to where the directory is. So if I press enter, you'll notice something important has changed with the prompt. Right. It now tells me that I'm in the directory extract. What was this tilde before? What's that shorthand for? Shorthand for the home directory, right? Which we know was /home/user and then whatever number you're in. Right, so now I'm user 9. The tilde is the short form for that. And when we need to move back there, it might be helpful to remember that. So we'll get you caught up on that. So let's see what's inside these files, and then we'll look at doing a little bit more setup and getting us ready to actually do a little bit of scripting to do some work with them. So you need to see what's inside a file. Right. So ls, let's see some of the file names that are here. I'm actually going to do a clear just to move it back up to the top and then run ls again so we can see. Makes it easier to track what's going on. So let's look inside one of these files, right? Let's just see what's in it. So the command that we often use to do that is cat. It stands for the concatenate command. And what it does is it takes a set of files that follow the command from the command line, and it then prints them out on the screen, one after the other. What it's really doing is concatenating those files together. Concatenation is the process of taking strings of text and joining them so they become one. And so just going to see each file as a string of text. We use it to look inside files a lot of the times because the command isn't going to get upset if you only give it one file. It's just going to stop after one file. So it'll print out the first file and then it will stop. So we might want to see what's inside. I don't know, which file do you want to see inside? Somebody choose one. You can just unmute or you can type one in the chat here. What file do you want to look at? Probably easier to unmute. First person to choose. Which one do you want to see what's inside? Imagine an advisor or a colleague gave you one. You want to see what's inside the gene one. Perfect. Let's look inside the gene association one. So gene, tab, right? There it is. So I'm using tab completion again so I can be fast. So it's cat space and then type what you want to look inside. And I'm going to press enter. And oh my heavens, it's just dumping a lot of stuff on the screen. And it's going to dump and dump and dump and dump. If it gets annoying at a certain point because it's printing out the entire file and you're going to hold Control and press C, which I just did, right? And what it does is it stops the computer doing the current process on the shell. Works most of the time. There are certain programs that are going to disregard it, but many of them will work really nicely for it. And at the very end here, sorry, it's a little upset with me now because what it's done here is it's filled the buffer for the terminal. The buffer is the memory of all the things that came before, and running this is eating a lot of that space. So it slowed me down a little bit, but we're back now. So you see this little caret symbol and then the C, that shows Control C, right? So it was printing stuff, and then I passed it a Control C, and it's like, okay, I'm done. And it brought me back to here. So that's one way to look inside a file. And if it's a really short file, it's great. But if it's not a really short file, that's a problem, right? Not a helpful thing, right? Because there's a lot of stuff here as I start scrolling. I don't know if you can see the little handle on the right-hand side, but it's barely moving. Like there's just so much stuff in here. But it starts to give us an idea of what's inside. So clearly there's a lot of genetic sort of data in here. I'll tell you now that a lot of the stuff that's in here has to do with a fly called Dropsila that's used for a number of baseline genetic testing and experiments, particularly with mutation and crossover. Not my thing, but that's what this is, and it's useful for us to use. So how do we peek inside the top? What if I just want to see the first few lines? So we'll keep using this gene file for this. So the command to do that is head. Sorry, let me go clear here. The command is head and then the file name. And if I press enter, it's going to give me the first few lines. Right? Well, how many lines is it giving me? How many lines do we get here? Five. 1, 2, 3, 4, 5. It's more than 5. These ones alone are 5 lines. We've got some word wrapping here. The real point is we don't want to have to count them. We want to be able to know. And we want to know because we want to tell it exactly how many lines we want it to show so that we can expand or contract it as we see fit. So I want to use the head command, but I want to pass it a flag, right? Let's say I only want to see the first 5 lines. Well, I'm going to pass the head command the N flag for number. I'm going to put a space in, and then I'm going to give it an input. So here we have command, flag, input into the flag, and then the file that we want to run it on. And that'll give me the first 5 lines. If I want to see the first 6 lines, I'm just going to press up. Now we have that first kind of specific base information that's coming out after all the header information in the file. What if we want to look at the bottom? If the command to look at the top of the file is head, what do you suspect the command to look at the bottom of the file might be? Oh, I love them. It's tails, right? Think of a coin, heads and tails. Although toes is what it should totally be, right? It should totally be that. Maybe we should have shoulder and knees to see middle parts of the file too. That'd be beautiful. I love it. I love it. Unfortunately, the command is tail. And so test that, right? Do tail and do tail with the -N flag, right? How do you see the last line of the file? Somebody type it in the chat here. I'll type whatever you type in. Yeah, thanks, Gonzalo. Tail dash n gene. Uh-oh, it's upset with that. What have I left out? Yeah, the 1. So not a problem. Gave us an error. We can read the error. In this case, the error is fairly helpful. And so we can just go back. I pressed up to get that line back, and then I just cursor across, put in the 1. Boom, there's the very last line of the file. So here you can imagine you could have some very, very massive files. And if you were forced to look inside these files using some standard tools, perhaps word processors, for example, it could be real pain for you to scroll all the way to the bottom to see the end, right? Some of these commands and the ability to just peek inside rather than open some monstrous file and just see the first line or see that last line or grab a random line from in the middle, they're very powerful tools, right, to do this sort of work. And they're very, very fast. When C was being written, things were being written in the shell to run C. The shell was written to run C, and C was written to run the shell. There's this really close, tight loop between them. So they can be quite speedy and efficient. So you can now log into the cluster. You can look around where you are a little bit. You're able to move in, make a directory. Right? You're able to clean up messes that you have. You're able to pull down files. You're able to move into other directories, right? And you're able to look inside files now. You can either look at the entire file as a whole using cat, or you're able to see tops or bottoms of files, right? And so you can look in some of the other ones here if you'd like to poke around in those. But that's a lot of stuff, right? But we want to be able to do a little bit more. We want to get some information about the files. So the first thing I'm going to show you is how to get them about information about the files as a whole in the directory, a little bit more advanced use of ls. And I'm going to show you a tool that's going to allow you to figure out what all the flags are. And then we're going to move on quickly and we're going to do a little bit of, excuse me, getting some information about each file individually. Vladimir.
I have a problem. Sorry.
Yeah.
So when I enter tail dash n space 1, I actually put like space between dash and n. So now it's telling me standard input, and I can't do anything.
So let me recreate that. So is that what happened? Yeah.
Yes.
So what's happened here is we put a space between the dash, the space, and the end, right? So it's getting confused, right? It's like, well, we're back to, it's expecting something other than what we have. So hold Control and press C, right? It's basically stuck in a loop that you could finish typing out your command and so on in, but it's not worth it. So Control C will kick you back out to the prompt that you should be in. Does that work? It's not working for you?
Nope. Oh yeah.
Control C, not Command C.
Yeah. Control C.
Yeah, or not Windows C, whichever one you're in.
I was on a different window probably, so I was pressing like on
Absolutely.
Control C,
Oh,
yeah.
I've so done that. So done that. Too many terminal windows and other things open. Okay, but you're good now?
Yeah, thank you.
No problem. So let's look at some more details, right? So ls, right, if we want more details about these files, ls will tell me what's here. But if I want to know things about them, then I want to pass ls the L flag. Again, no space here. We'll get into trouble. ls space dash L. And if we run this, the L flag is the long format. Right? And so it's going to give me some information. At the front, it tells me some information about permissions. That's what those R and W's are. R for read, W for write. And there's different sorts of users on the system. The user, the group the user belongs to, etc. And that's why there's a bunch of those at the front. We'll come back to those later today. right? It tells me who the user and the group that own the things are. It tells me how big they are in bytes, which is really helpful unless you're really good and use these systems a lot. We'll look at fixing that. And when it was built, right? When it was put together. And so you can see those files are kind of old. They're from January 2016, but they're still useful for this. So that's why we're using them. And then there's the file name. So we can get some more information about them as well. Command I want you to know, because so far I've just been bringing stuff up. When it gets to learning the command, you're often kind of stuck asking somebody what the command might possibly be. But once you know what the command might be, then you want to know what all the options are for it. And there's a really slick tool for that. And that tool is called man. It's the command. It's short for manual. It does have some gender bias built into it. I apologize. They weren't thinking about that back in the 60s, 70s when they built this thing, unfortunately. So man, and then you pass it the name of a command. So we're going to man ls. We want the manual for ls. And it's going to open up an application in the terminal, right? And this terminal is, so you can scroll up and down here with your arrow keys. If you have a mouse wheel, it'll probably let you scroll up and down with that. If you're using a trackpad, you can probably use 2 fingers to scroll up or down. And it will show you all the flags that there are for ls. So have a little look at that. What I would like you to tell me is what is the flag to make the size of the files human readable. I don't want it in bytes. I don't want to have to do the math to figure out like how many, try to count how many decimal places to figure out if something's a kilobyte or a megabyte or a gigabyte or a terabyte. I just want it to do it. So what's the flag for making it human readable? So look on your own screen and grab that. Then let me know. Yeah. So we have a suggestion here that might be -H. So if we scroll down here, right, if somebody gives you a flag and you're like, what's that flag? You can type man and then the name of that command and you can scroll through. They're typically alphabetical order. Sometimes they're organized by different subgroups or whatever, but you should be able to find it. And here it is, human readable. You can also use -- and then write it out in full, but the short form is -H, right? So if you use it with L, which is the long format, it'll print human readable sizes. So we're going to get out of here, but before we get out of here, I want to show you how to get help. And the first letter of the word help is H. And so if you're inside the manual pages and you press H, it'll bring up the help menu. And you can scroll around in here and figure out how to get some help. I'm not going to spend a lot of time in here, but I do want to know how to quit. So how do I get out of the help page? What's the keyboard command for that? How do I exit? Yeah, it's going to be Q. So I'm going to press Q right now. It takes me back here. And I'm going to press Q again. It brings me back here. So I'm going to run ls-l with the H command. And so now I get the long format with all that extra file information. But in addition, I get the bytes converted to megabytes, right? So I can see that dmel is pretty big. The very first one, dmel all, 74 megabytes. It's pretty massive, right? Whereas the others are much smaller. So if you had to work with files and you're concerned about their size and how long processing them might take, it's the way for you to look inside and grab that information. So, got one last thing to do before we move on to break here, and that is start using some other commands to look inside the files and then look at how we can start joining commands together. Probably take us about 15 minutes, and so we should be ready for another break at the top of the hour. Before we do that though, there's some questions that it would be helpful for you to have answered before we move on. Going once, going twice. Okay. Please, if you change your mind, please ask them in the chat or just unmute and we'll make sure you get them answered for you. So I'm going to clear. And I'm just going to run a regular ls again so I have the list of file names because I don't have them memorized. So what we might be interested here is in knowing how many lines are in a file because we want to process the file, right? Or perhaps we have a device that's producing files for us and we need to check to make sure that it did its job. It may be the case that, you know, it will always produce exactly 500 lines. And if it didn't, something's wrong. We want to know that. Or it might be the case that, you know, maybe it produces 500, maybe it produces 700, but it certainly shouldn't only produce 10. That's going to be a flag for us. So we want to know how to count. And that's the prompt for this next bit. We want to count the number of lines that exist in these files. And so if you were designing the system and you needed to make a tool to count lines, you might be interested in counting other things as well. You might want to count words, and you might want to count other components of this. The command for doing these kinds of counts is WC. So let's count how many lines are in one of these SRRR things, right? So you're going to watch me tab complete my way through this. I start by typing SRR and then I press tab. Well, it only fills up 3070. Doesn't fill, I want to look at the first one. Why is it going to 3070? Where's the rest of it? If I press it, it makes a little dinging sound in my ear. You probably can't hear that. But if I press it twice, it only gives me a list. Right? Why won't it just give me the first file? Yeah, they all share the initial part, and it's not going to decide which one to choose. So we're going to have to go a little farther. So I have to give it a 2, 3, right? And then I can press tab again. But now it's still not sure what to do because there's 2 files that start with that from the beginning. So I want the first one. The moment I put that in, I can press tab and it'll grab the whole thing. So we're going to run WC on that. And I get 3 numbers. Your task is to tell me what those numbers are. So how might you do that? How might you figure out how this command works? Before you do it, tell me what the 2 ways are. I don't want the answer yet. I want to know what are the 2 methods that are available to you right now for figuring that out. I don't want the answer yet. I want to know how you might get the answer. Guessing is one. I don't want guessing. You could absolutely run man WC, right? So you run man WC and you can read the manual pages. And that's how it used to be done when people were connected to these machines that were only connected in very, very forced ways to other machines. You have another option available to you. What is it? Well, you could ask for help. Some have that available, some don't. You're missing it. Google, boom, there it is. Yeah, you browsers, you have tons of help features that are out there on the web. They often come with really beautiful examples. Ask Camille is another one. There's lots of options for you. So as much as I've shown you the man pages, and they do have a role to play, you have a resource that is fantastic in comparison. And that's asking for help, right? So if you went and you typed, how do I use the WC command in Linux or the shell? You get some really nice answers for that. So look at one of those resources and tell me what we have here. How many new lines? How many words? And how many, what's the byte count? Right. So this is a pretty regimented file, right? It's got exactly 4,000, 2,000, 20,000 lines, right? It's got 40,000 words, you know, which is telling you that each line only has 2 things on it. And then the byte count will shift around a little bit depending what those characters are. So next question, what is the flag with WC to only have the number of lines displayed? So we have the suggestion for -L, right? Possibly dash lines. Let's go with -L and see if that's going to work for us. So WC. So I'm just going to press up, cursor across. Well, actually, here, I'll show you another slick trick here. If you need to get to the very start of the line after you press up, you can use Control and A, right? And you should be able to see my cursor jump to the very beginning of that line. So you only got to press over a little bit for that. If you want to get back to the end, you can hold Control and E, right? Control and E for the end, Control and A for like alpha or the beginning. I'll take you back. So I'm going to put in -L with a space. So that's the flag. And there's 20,000 lines. So that will show me all the SRR. That shows me for this SRR. How do I get the list? I want WC, I want the line count for every single SRR file. So I'm asking you to apply some things you've already learned in a new way here. I'm asking you to make a guess. So given the features that you've had for selecting multiple files all at once, can we combine them here? So I got a wildcard for a name. You're right, we do want wildcard for a name, but I'm asking for the specific implication here. There's a case of it. So let's try that. Gonzalo has given us a suggestion. So let's type it out here. WC-L SRR. And I could probably just get away with S because nothing else starts with SRR star, right? And let's run that. And I get the line count for every single file. It's very clear that these files were produced with very particular intent to have exactly the same line numbers. And then at the bottom, as a bonus, we get the total. Vladimir. Unmute, ask away.
Sorry. So I had some internet problem, and I think I was kicked out from the login. Shall
It
I
happens. Just log back in. Just log back in.
Yeah, okay, I'll do it now.
Over the course of your life, if you are using these remote systems, you'll get kicked out. Just log back in and come back in. Yeah. So we see we've got all these files. They're pretty nice, right? Or they look the same, right? So that should give us some confidence that they were, you know, even if they were produced incorrectly, at least they were all produced in the same way incorrectly. And we can do some work with that. So given that these things seem all pretty much the same, let's repeat something that we did before. Let's make a directory. What's the command for making a new directory? mkdir, right?
Dir, yeah.
Dir, right? And they're all FASTQ files, right? So let's call this FASTQ. And then somebody was asking about moving the files. Let's move them. Does anybody remember the command that popped up in the chat for moving files? Yeah, it's mv, right? And how do I move all of them all at once? I want to move all the FASTQ files. Yeah, I'm going to use a wildcard, but I want you to tell me what to type out here for it. No, you're not restricted to a file format. You could restrict it to a file format. So let's try it. Okay, so let's try it. Let's try fastq, right? So MV, and I'm going to type a little different than what's in the chat here. I'm going to go star FASTQ, okay? Well, it's really not happy here. What have I not done? What am I missing here? Yeah, I have to tell it what I want to move. I want to tell it where I want to move it to, right? So that's missing. So I want to move fastq to the directory fastq, right? Everything that ends in fastq, I want to move to the directory fastq. So let's do that. And it's going to get upset. Why? Look at the error message here. What have I done that's preventing this? Oh, we've got a note in the chat here, the dot. Yeah, the dot's essential here. Basically what I've asked it to do is anything that has FASTQ at the end of the name, which includes it if it's at the beginning, if there's nothing else before it, I wanted to put in that directory. But I've named the directory FASTQ, so I can't put it in itself, so it's going to get upset with that. Right? So the trick here is to put the little dot in front, or to name it from the beginning, SRR wildcard to the end, right? There's different ways around that. I wanted you to see that. So I'm just going to press up. I'm going to cursor across, put in the dot. Now it can't find anything. What's happening here? If I do an ls, we see it already moved them, right? It moved all the files in, and then it hit the folder, and it got upset about the folder. So my trying to fix it again, we don't have to worry about it. It's already done. But you could see how, if you weren't checking each time you did something with ls, that you could put yourself in a state of confusion. So how do we get two last commands here before we move in? Oh, question here. The wildcard can be at either side. It's going to depend on the structure of the file name that you want to work with, right? There'd be no point in sticking it at the end if there wasn't anything that came after it. But you can use, here. So I will answer your question in just a second, Nicholas. First question for the group, how do I actually change directories and go into this fastq folder?
CD and the name of the directory.
Yeah. I'm going to go in the fastq folder. I'm going to do ls. We can see all the content that's here. What if I only wanted files that I only want to see the #2 files, for example, right? Maybe I just want to see the sizes of the #2 files. So I'm going to run ls, right? Well, actually, yeah, we've got a great example from Camille in here, right? So we'll just steal that. You can go SRR, whatever. And then I want all the ones that have the #2 in them, and I don't care what they end with, right? So if I run that, it will just give me the human readable long output for all the SRR files that are _2 before the FASTQ. So you can use the asterisks in multiple places. Does that help, Nicholas? Perfect. I want to show you one last thing, and then we'll give you another short break. So what was my command for seeing the output of all the word counts for all the SRR files? What did I type in for that? I want to print it on the screen again. Maybe we have to make a report. Right? So what's the command? Yeah, WC. What's the flag for lines only? -L. Yeah. And then I'm going to use the exact same wildcards you just saw, SSR star. All right, gives me this on the screen. Now, you can imagine I might have a lot of these files. Maybe I have to provide a report to somebody to show that all the line lengths are the same. And well, I could come in here and I could do a copy and paste. That kind of works for now, but it's kind of clunky. It also isn't happening on the remote system, and maybe that's where I need that file to be kept. A copy and paste would be happening on my local system. So I'm going to show you a way to take this output and then redirect it to a file. Okay. So what you're seeing right now is it dumping to the screen. In the shell parlance, the shell lingo, the shell language, it's referred to as standard out. And we're going to redirect it to some other place. So I'm going to press up because I want to run the same command. I want word count, 4 lines only on all the files that start with SRR. But what I want to do is I want to redirect it. Right? And so I'm going to use a greater than symbol. Think of it as an arrow that's pointing some other place. Right? And I'm going to make a file. I'm going to give it a file name called linecount.txt. I'm calling it line count because it's going to hold some line count. I could call it anything. And I'm giving it the .txt extension because by default, these files are all text. Unless there's some specific formatting that you're putting in there, maybe it's a comma separated values file or something, you probably just want to call it out as a raw text file. So same command as before. Now I've got the greater than symbol. It's got spaces on either side of it, and I'm pointing to a file name that I'm calling linecount.txt. I'm going to press enter. Now I ask the question, what happened? How do we check? Somebody we haven't had a response from. How do I check? You just swapped to typing it in the chat instead of talking, Vladimir. That's cheating. We need somebody else. It's all right. It is LS. So if I do LS, I do see that I now have a file inside here, right? It's called linecount.txt. And how do I look inside that file? I want to see all of it because I know, I suspect it's not very long. How do I see all the content of that file? Cat. So let's do cat linecount.txt. And there's the content of that file, which I could then give or pass to somebody else. It's not going to change. And if I needed it for a report or this was my report, it would be available for whoever needed it. So that last bit that you've seen, this redirection, that's what they're often referred to as. These are going to be really important as we move on because this is the basis on which we can take a simple command and then start chaining commands together. So we can build what's referred to as a pipeline for processing our information. And that's what we're going to pick up on after break. Because once we can do that, once we can chain these commands together, then we can turn them into mini programs to do our work for us. We're only looking at, I don't know, what is it, like a dozen of these things here, but you could imagine having 100 files or 1,000 files that are all formatted the same way and you want to pull some information out of them. You don't want to be opening them up one by one in your graphic user interface. You want to be able to process them quickly using this text-based interface. So that's what we'll come to after break. So we'll start off again at 10 after. So you got about 5 minutes. As with the last break, I'll be here throughout. If you have questions, happy to answer them. If you have questions about other parts of the Bootcamp series, happy to chat about those as well. If you have questions about any of the Python things that are coming up, Chris is here. He can answer those. If you have questions about any of the scheduling features that are coming up, Camille's here. He can answer those. Okay, let's roll. So hopefully you're all back. We're picking up where we left off. We're able to do some redirects now. So we can take what would normally be printed on the screen and we can pass it to a file. We're doing that with a little greater than symbol. Clear. The greater than symbol, when you use it, will always overwrite whatever content was already in that file. So if I was to run the command again, I don't expect you to do this, but we could do it with the command that Camille was helping us with before when we were trying to demonstrate how you can use the wildcards in multiple places. So this should do word count of lines, but only for the number 2s, right? The underscore 2s of the SRR set, and dump it into line count. If I press enter, silence is golden. It doesn't complain. If I do an ls, you can see line count still here. And if I do cat on line count, you can see that the number is less, right? So it's important to keep that in mind. Single greater than will overwrite the content of that file. If you want to append the content, you want to add new content to it, then you need to use not the single greater than, but you need to use a double greater than, right? You can almost see them adding together, inserting into each other, right? This is the command to do that. So I'm going to modify the SRR number 2 file of line count that I just did by adding in the number 1s, right? And so what do you expect to see if I run this in that file? If it appends as I'm telling you it is, what would you expect to see? The file's in order. What order? Yeah, first the 2s and then the 1. That's the perfect piece. Thank you. So let's run it and then make sure it does that. So I'm going to run that. I didn't make any new file. I don't know why I'm typing out last, it's just a habit. But let's cat. I'll just press up to get the cat because there it is. Right? And so we see the first block, all the 2s and then their total. And then we have all the underscore 1s and then their total. Right? So there's 2 different redirects for creating files. One builds a new file and overwrites anything that was there, and the other just adds new stuff. If you're creating the file for the first time, you can, and you want it to append, you can just use the append. It'll just create the new file and just fill that content in as if you would use the single one. So I need to show you a new command. A new command. There's only 2 or 3 new commands to show you, and then we're kind of done with them. A new command and 1 more redirect. Let me show you a command. I'm going to go clear. Do ls so we can just see what's in it. It's a command called grep. This is the GNU regular expressions parser, but as Chris pointed out very helpfully last time, it stands for globally replace regular expression in print or something like that. So the G, that's what the G stands for. And the RE is for regular expression and the P is for print. And what it's going to allow us to do is, it matters for us because it's a search tool. We give it a string to search for, and we give it a file to search for the thing in, and it will go through and it will find us that file, right? Or find us all the instances, all the lines where that instance occurs. So these are all genetic things, right? So let's look for some genetic information. Let's look for genetic strings in here. And simply because it was a movie, and so I can remember how to spell it, we're gonna look for Gattaca, G-A-T-A-C-A, inside of the, oh, let's look inside the first SRR one, right? SRR 3023_1 dot, right? And then tab completion for the end of that. So we're just going to do 1 file. and we're going to look for Gattaca inside it. And so it prints out each line for us, and it helpfully highlights in red each instance of GATACA, right? Which is nice, except maybe what I want to know is how many lines in this file have Gattaca in it, or any other command that I might pass. So how do I get that? How do I get that? What would be nice to do? I'm not asking you about actually how to type it out on the screen, because I'm going to show you that. What I'm asking you is to tell me what would be nice to do. Given the commands that you've already seen, what would you like to do in order to make this count? Right? You want to count the number of lines that have Gattaca in them. Given what you've seen, what would it be really helpful to do? You want to find the location and count and print to a text file. Now you already have the tools to do this. You just don't know how to connect them together. So I've given you the tool for finding the instances. What's the tool for counting? WC. Absolutely. You want to take the output from this and you want to pass it to the word count command. There's a redirect for that. So you've seen a redirect that allows you to take the output on the screen and put it in a file. You've seen a modification of that redirect that allows you to take the output of a screen and add it to the end of a file, so you're not clobbering what was already there. The final redirect that we're going to look at today is going to allow you to take the output of one command, and rather than dumping it in another file, it's going to allow you to pass it to another command as input. This is how it works. So I'm going to start by clearing, right, just so we don't have to see all that stuff. It's going to be distracting. There's a lot of GATs and Cs in there. So I'm going to press up to get back to the grep Gattaca SRR, right? And what I want to do at the end is pipe the output of this command to the WC command. And so on your keyboard, on the right-hand side, just above the enter key, there is likely a slash, and above it is a straight up and down line. Depending on the language variant of your keyboard, that line may be 2 dashes on top of each other, straight up and down. When you type it, you're going to have to hold Shift and press on that key. You should get a straight up and down line on your terminal, right? This is the pipe character, right, as it's referred to in the shell, and allows you to take output from the left side and pass or pipe it to the command on the right. And so I want to take the output from Gattaca, and what's my command for line counts? How do I do line counts? WC what? -L. That's right. Thank you, Cerise. So WC-L. And so if I run this, it should tell me how many lines have Gattaca in them. So I get my result. And my result is 72. So how do I do it for each? How do I modify this line so that it's going to do it for every single SRR? Not just the one that I was doing my testing on, because it's a single file and I can control that. Now that I know how it works, how do I open it up and do it for all of them? Yes. So let's try SRR star. So I just pressed up to bring that line back. Cursored over to delete what I don't need, just throw the star in, right? And again, we could get away with just the S here, but the SRR adds us some clarity. Press enter. And what do we get? Get the count for all of them. So might this be what you want? Maybe. If you want to know how many across all the files, this is great. It's just done. But what if you wanted to know the count for each file individually? Then what? Well, then we need another trick, because what we need to do is we need to ask the computer to run each individually, right? And so we're going to write a script to do that. So this will be the last thing that we do today, other than a little bit of wrap up at the end. So given where we are, it's possible that we'll go over a little bit at 4 o'clock, but I want to complete this for you. We had a little bit of sorting out at the beginning to get everybody connected, but we're all together now. We might go over 4 o'clock a little bit. Know that this is being recorded. If you have to leave, you'll be able to come back and grab that. I apologize for that, but it's just how it goes sometimes when we're doing remote work and trying to help a lot of people at once. So before we move into the scripting, are there some questions that you have that you would like answered about anything that we've seen so far? Because we're going to take what we've done and we're going to complicate it a little bit. I want to make sure that you're clear on that. Go once, going twice. Okay, away we go. So we're going to set aside our mini project here, which is building a little tool that's going to let us search through a whole bunch of files to find some set of characters that we want again and again, and do the line counts for each file. That's our goal. We're really at least 50, maybe 75% of the way there. We just need to stitch it together just right. We're going to write a little bit of program for that. But before we do that, we need to do a tiny bit of testing around what is a script and how do we make them work in the first place. The moment we got that solved, we're going to grab this content, we're going to throw it in there, and we'll be good. So we need to write a little program. And so we're going to need a text editor to write that program. There are lots of text editors that are available, and you could write this program on your remote computer and you could copy and paste it here into the terminal window. There's many different editors that are available inside the shell. Two that are really well known. One is called Emacs, another is called Vim. Anyways, they're two. If you're hanging out in the Linux world a long time, you'll probably find people that might come to blows over which is better, Emacs or Vim. We're not going to use either of them. We're going to use one called Nano. We're going to use it because it does exactly what we need to do and nothing really more. And so it's a really nice introductory shell editor, particularly because it prints out its primary commands at the bottom of the screen, whereas the other ones require you to start to learn some kind of almost secret feeling special keyboard strokes. When you learn them, it's super powerful. You can be very, very fast, but learning them can be a hassle. So we're going to set that aside. So the tool we're going to use is called Nano, right? And so we're going to run Nano, and we're going to create a new file, right? So we're going to pass Nano a file name. And why don't we just call it demo.sh. Right? The .sh is a commonly used extension within the shell environment to show that this is a shell file, usually a script, which is kind of a mini program for doing some work. So nano space demo.sh. And all of a sudden, the whole interface changes. You can see at the top, it tells me that I'm in Nano, gives me the version number of it, name of the file, and then at the bottom are a bunch of commands for actually using Nano. If you remember from holding Control and pressing C, that little caret, that little hat character that you see over the 6 on your keyboard, you see that before each of the commands here. So if I want to exit, I'm going to hold Control and press X, and I'll exit. So I can do that right now. I'll hold Control and press X, and it just brings me right back out. If I do an LS, I didn't do anything. I didn't edit the file. There's nothing made. It's just done. So it just set it aside. I'm going to press up twice to bring back that command, nano space demo.sh. Press enter, and I'm back in here. So I'm going to write a script, and you're going to write a script along with me, right? At the very end, it sometimes happens that people kind of get caught up, and spacing here can be a problem. I will copy and paste my code from here into the Etherpad, so you have exactly what I typed at the end as well. So if you're like, John, my fingers are tired, I just want to watch this, that's totally fine. If you want to type along, I think that's the preferred method for learning. You're welcome to type along, and we'll catch you as you get stuck. So, writing a script. Our first script is just total demo. Let's make sure that we can even run a script that says like, hello world, or our script worked. It's going to take 2 lines to do it. First line's, strictly speaking, not entirely necessary, but it's good practice, so we're going to do it. So it's going to start with a pound, right? This is holding shift, pressing 3 on the keyboard, and then an exclamation point. So this is called a shebang, and the hash, this combination tells the shell when we try to run this program, it's going to open up this little bit of scripting and it's going to read it line by line, not to pay attention to this line, because what it is, well, not to pay attention to it in the way that trying to run the line, it's meant to tell the shell what language everything below it was written in, right? Most of the books on your shelves are probably languages you recognize, but you can imagine a language that you don't recognize at all. Wouldn't it be really nice if at the beginning it said, oh, this is Farsi, right? Or this is Arabic, or this is Spanish, or this is English, right? Maybe that's Old English. That's what this line is going to do. And so we're going to tell it what language it is by telling it where to find the info it needs to interpret the language. And so it's going to be in /bin, right? This is a folder that exists on most Linux systems. I'd be surprised if it wasn't on one. Think of it as the binary folder or the bin folder. It's where most of the central programs are located in subdirectories. And it's going to be inside the BASH subfolder. What is BASH? What is it? Why would we care about that? It's the born again shell. Perfect. It's the shell we're in right now. So if somebody was to take this script and run it someplace else, you saw at the beginning, I had the option to run this in Z shell because that's what Mac has moved over to. I could still run this script because Z shell would open this up and go, oh, yeah, I'm Z shell, but this is a bash script. I'm going to go to bash. I'm going to run everything below it from that directory that's the bash directory. So it's going to make it work for us. So that's the very first thing that we do. You can often get away with not doing it, but if you were to move to a different shell or a different environment, it might cause you a problem. So the command that we're going to run is echo, right? And all echo does is prints out what's to the right of it. It's literally echoing back whatever you type in. So you need quotes around it. So I'm going to write our script, a little exclamation point there, just because we're excited. If it can print this out, that'd be a really good thing. And that's going to be our demo script. So we have the shebang. It's a hashtag. It's a hash or a pound symbol followed by an exclamation point, /bin/bash, and then echo space, double quotes, our script work, and double quotes. That's it. Now I'm going to hold Control and press X to exit. And Nano is smart enough to know that we've made some changes and we didn't save it. So it's going to ask us if we'd like to save this file. Of course, the answer is yes. So you can see the Y beside the word yes there. Doesn't matter upper or lowercase. I'm going to press Y. It's going to ask me the file name to write next. The reason it has this is because when we ran Nano, we passed it a file name. We suggested a file name at the beginning, demo.sh. If we just typed Nano and pressed enter, this would be blank. We'd have to type something in here. But because we already suggested it, I can press enter. Select to accept demo.sh. And it brings us back. If I do an ls, I see I now have a file here called demo.sh. Right? What was the command that we put in there? It was the echo command. Let's test that. Right? Let's make sure it just works here on its own. I'm just going to echo hello. And it does. So let's run it. Let's see if it runs. If it runs, what should we see? What should we see on the screen? What do we see on the screen if it works? Our script worked. Yeah, absolutely. Thank you. So let's try it. Demo.sh. Let's just type it in, run it, right? And it tells me command not found. So this is going to be frustrating for us because we see it right here. So to know what's going on here, you have to remember back to the beginning. What's happening? How does the system find commands? Yeah, it's going to look in the path. And so the very first thing it expects after that prompt is a command, and it goes to the path, which is a very special, very specified set of files and folders. And I guarantee you there is nothing in there called demo.sh. And if there was, it wouldn't be our demo.sh, so it wouldn't help us. So we need to, as Pablo's suggesting, we need to run the file. And what Pablo really means there is we need to say, don't go looking over there for it, run it here, right? Look here, run this thing. So we do that as follows, right? We're going to put a dot and a slash, right? The dot means here, right? The dot means here, and I'll come back to this in just a moment to make it a little clearer. The dot means here. In this directory, right, find me demo.sh, right? So that's how we're going to do that. And we'll come back to the dot in a second to explain a little bit more about that. Might be a couple minutes, but we'll come back to it. So we're going to try and run it now. So again, if this works, right, as Gonzalo was saying, it should say our script worked. So let's try this. Burn. We have a new problem. Permission denied. So we are walking you through this because this is the reality of writing scripts. If you do it all the time, you know these things are going to come up. You're going to deal with them directly. If you don't, you're going to see them. I want you to see them here. I want you to see how we're going to solve them. Because if we can't even run an echo, right, our script worked echo or our hello world echo, then we're in trouble. So I'm trying to show you some good programming practice here as well, right? Before you go and write all the complex stuff, make sure that every step before it's going to work. So we need to give it permission. So what's happening here? Well, so let's go back to ls, right? We want to look at, well, first let's deal with the dash. Let's leave the dot for a bit. We'll come back to that in a second. So if we do an ls-l, right, get the long form. Remember everything on the left? What's the very first set of characters there? These R's and W's and dashes. Does anybody remember what I said these were? Yeah, those are read and write, right? These are the permissions. We're missing a permission. And that permission is execute, right? So on these systems, every file has three possible kind of states or modes. You can read to it, you can write to, you can read from it, you can write to it, usually includes read it. But can you execute it as a program? Can you run it as a program? And that's missing, right? We see it missing for all of the files, which is fine, except for this one at the top, demo.sh. We want it to be an executable. So there's lots of complexities around setting these modes. We're going to set them aside for right now. I'm going to show you just how to blanket apply execution mode to a single file. So when we do it as follows, I'm going to clear this. Right. I'm just going to run the ls-l again just to bring it back. So we're in the middle of the screen. The command is chmod, right? It stands for change mode. It's sometimes pronounced by people who use it a lot as chmod or shmod. And so what do we want to do? We want to add the executable mode. So space plus lowercase x to the name of our file, right? Demo.sh. If I press enter, silence is golden. It's not going to complain about anything. So we assume that it did it, but I'm going to check. So I'm going to run ls space -l again, and I should see x's. And so now we have the execute permissions turned on. Yeah, so we'll get there in a second, Abdullah. So let's try it now. So /demo.sh. It says our script worked, right? Which is really nice, right? So, question in the chat from Abdullah. If we do bash demo.sh, it runs without changing permissions. Why? It has to do with where the permission lies, right? So bash as a program already has the permissions needed. So bash permission, input into bash, those permissions subsume whatever. Like this is just an input file, right? Who cares? Like you can read it, you can write it. So bash can take it. Bash already has the permissions. You're good. But when you're on the shell inside the bash environment, the permission it's going to look at is the permission of that script file, right? It's not going to. You're invoking bash within bash, and bash is, anyways. That's roughly why it's happening, right? When you run that program has executable permission, and so it's going to run it for you automatically. So there's other ways around it, but what you really want at the end of the day is the ability to control those modes, because they're going to be files that you're going to want to make read-only. You can imagine what that's going to be. chmod space -r will take away the read, but -w-x will take away the writing and the executable. It's now a read-only file. Nobody can change it, right? Unless they also have the permissions to know how to do that. So we can now write a script, right? And our script can work, and it's super simple, and that's just fine, because now we're going to move in and we're going to do a few more complicated things. So again, I think we'll probably end at about 10 after, but we're close to being done. So we're going to continue to use the same file. We're just going to edit it. So I'm just going to press up here until I see nano space demo.sh again. So I'm not going to type it again. I'm going to press enter. It's going to bring me back in here. So we don't need it to say our script worked anymore, but having a line like this can be helpful in your code from time to time, just to make sure that it's still functioning. So we can turn this line off just by putting a single hash or pound in front of it. So that's what I'm going to do. So if we save this, went back out and ran it, it would just do nothing, right? It would just open this, there's nothing to do, and so it's going to get push that out. So the first thing we want to do is we want this to be able to handle, to do what we were already doing on the command line, right? So I'm going to type that out here, but you might be able to copy and paste it from what you were doing, right? So we were running grep. Basically, the point is this. every single line that you can type on the command line in this call and response sort of environment, ls enter, grep enter, wc enter, you're going to make a list of these in this file. And when the program runs, it's going to walk itself through those. We're going to be able to add some other parameters around it, things like loops and conditionals. We're just going to do a loop today that allow you to have a little bit more control. But you could type them on the command line. The benefit of typing them here is that it allows you to edit them much more easily and to take that set of commands and move them around. They're very portable. You could save them, you could give them to a friend, things like that. So, but let's make sure that we can at least run grep. So we're going to grep Gattaca, right, off of all the SRRs, right? And we're going to pipe that to WC-L. Right? That was our command on the command line, right? I think so. So I'm going to save it, exit, Control X to get out, and press yes to, I'm going to keep the same file name. And now I'm just going to press up till I get to ./demo.sh. Right? I'm going to run it. So it works for this too. Again, I'm trying to demonstrate you useful practice here. You make a change, you come out, you make sure it works, you go back in, so you don't get a whole bunch of changes and you can't figure out where the break is. So I pressed up to get to nano space demo.sh again, press enter, I'm right here. So this works, but it's not quite what we want. Okay, it's not quite what we want. So I'm gonna comment it out, right? So it's just gonna be ignored, but it's here for my reference as the programmer, for your reference as the programmer. So we're gonna write some code to do this. And we're gonna use some of the things you've already seen to make it happen. So what we're gonna create first is a loop, because we wanna do this grep thing, but we don't want it to do it for a bunch of the files and then pass all the content over to word count. We want it to choose a file, pass that to word count, get the output. Choose the next file, pass that to word count, get the output. Third file, until they're all used up. So the kind of loop that we need here is called a for loop, right? And so what a for loop does is it takes a container, looking around to see if I have a container here that might be useful, right? Do this, right? So I have this bowl, right? And then this bowl is a bunch of pocket change and some other stuff. So the for loop says for each item in the container, so for each item in the bowl, take it out, do something with it, and set it aside, right? It's still in the container physically, but conceptually we've counted it, right? We're not going to keep putting the same ball back in the container and try to count balls and get like 1 million when there's only 2 in there. So for each item in here, boom, here's a loonie, right? So I'm going to take it out, I'm going to do something with it. And the thing I'm going to do is tell you what it is. I could do something else with it. I could spend it, I could throw it, I could put it in a different container. For each item in the container, do something. Loonie. Tiny toy keys, right? Some money that I'm not sure where it's from, but it has a hole in the middle of it, right? Et cetera, et cetera. I'm going to go through it again and again. And the for loop will go on until everything is done, because it's a for each item in the container loop. So to do that, I need something that I can, every time I pick that object up, that next object, I need a name that I can attach to it. The thing I'm holding, right? That's going to be a variable for us. So with that background, I'm going to write some lines of code here, and hopefully that adds some clarity. So for, right, file, I'm putting this in capital letters to indicate that it's a variable. It doesn't have to have capital letters. And I'm calling it file because those are the things I'm working with, and that has meaning for me. I could call it capital X. It would be a terrible choice because I'd come back in later, I'd forget what I did. So for file in, right, SRR star. So that's going to give me a list. SRR star gives me a list of all the things that start with SRR, right? This is going to grab each of those things and assign its name into the variable file. I'm going to say, sorry, I got a cat that thinks it's going to spend some time with us here. It should be fine, except he has terrible claws. He doesn't fit in my lap. So this is the setup. For file in this, so for whatever variable name, in this list of things we're going to choose, I declare do, and I declare a done. And between the do and the done are the things that are going to happen to that variable, right? The thing that was picked out of the container. So why don't we echo file? And to call the variable back again, as opposed to create a new variable with that name or overwrite it, we need the $ in front. So when we first declare the variable, we can just use it as a variable would be. But when we call it again, we need the $. So what this should do is print everything from SRR, right? It should print each line as each file on its own line, right? So I'm going to save this. So I'm holding control, I'm going to press X. We press Y to save it. And I'm going to keep the name demo.sh, but if I made changes, I wanted a different version, I could do that here. Now I'm just going to press up to ./demo.sh. I'm going to run it. And so what we've done, what command have you recreated here? What command have you recreated? Something close to it anyways. What does this look a lot like? LS, absolutely, right? And if you were to go into the folder with LS and find it, you're going to see stuff that looks similar to this. Now, there's a lot more that LS does, so it's going to be more complicated, but in principle, this is what it's doing, right? In principle, this is what it's doing. So let's go back and pressing up twice to get to nano space demo.sh. I'm going to run that. So if we can do this, we can just print the file name. What do we actually want to do? We probably want to use grep, right? So we don't want this. What's the line I need to type here? Type the first piece for you. Grep, Gattaca, what? What's the next part?
File.
File, but not just file. What do I need in front of file? $sign file, right? File, right? And then the rest of it should look like up top. Sorry. So instead of passing it the list of SRR star, which we know produces a whole list, we've just seen that, we're passing it file, which is the first item that was taken out of the list. When that's done, it goes and takes the next item out of the list, assigns it to file, will run grep Gattaca on that, etc., etc. Okay, so I'm going to, excuse me, exit. I'm going to choose yes to save. I'm going to keep the file name demo.sh. I'm just going to press up to get back to /demo.sh, and I'm going to run it. And if it works, we should see the numbers for each of the files. Right. So that's pretty slick. Now, we have time to do one more thing with these before we move to wrap this up. So there's a number of ways that we could go here. Let's grab something from you. Given where the program, what the intent is, what would be something that would be helpful for you to see here? What would you, if you were writing this program, what would be something you'd expect it to do? Boom, let's do Pablo's, first one up. yeah, just put the name beside the file. The other thing that comes up sometimes is you want to see the total count at the bottom, right? But putting the name beside the file makes a lot of sense, particularly up front, probably the first thing that we should do. Right? So we're going to edit the file one more time, assuming everything works. Might get a hiccup and we'll have to make a change. And then we'll move to wrap everything up here. So I'm pressing up to go back to nano space demo.sh. So for us to do that, what we're going to need is we're going to need a line here that's able to echo back two things. It needs to echo back the file name and it needs to echo back the count, right? And for that to happen, we're going to have to turn this initial variable into, this initial calculation that we're doing into a variable that we're going to call count. So it's going to be straightforward because I know how to do it already. If you hadn't already done this, it'd take you a while to figure out the syntax and so on. So here's the part where there's a little bit of, might feel a little bit of magic that's happening here. I apologize for that. But the point here is for you to see in principle what's happening with these shell scripts. They're just commands that are run on the command line. That we move in here with a few little variables to allow you to just have a more flexible experience, right? You can repeat this over and over again. So you don't have to write all this out again and again, even if the files change, right? So let's do that. So I'm going to create a variable called count. And I'm going to assign it this. So my assignment operator here is going to be the equals sign $, right? Followed by everything else inside that I've already typed needs to go inside parentheses, an open parentheses and a closed parenthesis. That will make me a nice variable called count. If you put spaces before the equals sign, you leave out the $, and I have to admit, I don't remember the role of the $sign here, you're going to have problems. So count equals, no space, $, no space, parentheses, no space. Then the grep line, as you already typed it, close parenthesis at the end. So once you have that, then what you can do is this, echo $ file space $ count. So I'm going to exit now. Actually, exit now. I'm going to press yes to save the changes. I'm going to write it to the same file I've been using. And I'm just going to press up twice to get the /demo.sh and press enter. And well, Pablo, we just did what you asked, right? So now we have the file name beside it. Okay. I'm going to do two last things really quick, and I'm going to do them fast. I don't expect you to follow along with them. I'm going to copy and paste this final bit of code into the Etherpad so you have it. So just for the sake of time here. So I'm coming back in here. There's two other things that you might be interested in. We'll set aside doing the summation. You might be interested in actually writing this to a file, right? Variable names in capital is a convention, Abdullah. It makes things a lot easier when you look at these scripts. So here's what we're going to do. What if you didn't want Gattaca? What if you wanted different things all the time? Wouldn't it be helpful to know that? Right? Wouldn't it be helpful to change that without having to come into the script, but you could pass it from the command line? Well, the convention for doing that is $1. $1 means the first thing after the command. $2 means the second thing separated by spaces after the command. $3 and so on and so forth. So I'm making this change. I've removed Gattaca and I put $1 in there. I'm going to go Control X, take it out. I'm going to say yes, press enter. If I try to just run it now without anything after it, it just sits there. It's waiting. I'm going to hold Control and press C, C for kill, to stop that process. Press up to get ./demo.sh back again. And I'm going to pass it Gattaca. I could put anything in here, I think, but I'm going to put Gattaca in there so I can compare it with the answer above to make sure it's doing what I expect. And that's what it does, right? And so now we have all the counts for Gattaca. If I wanted something else, is there anything that's like GGG, TTT? I don't know. Let's run it. Let's find out. All right, now we'll get all the counts for that. All right. So we've just generalized our program. And there's other things that we could do to it as well that we're not going to do, but you might want, right? You could set a sum at the bottom of each of these. So it would do it for each of the individual files and then give you the total at the bottom. That would be a nice feature to have. Another one would be that it would print on the screen, but maybe it also saves it to a file, right? You can imagine how you might do that with redirections inside the script itself. So we've created this little script that does some work for us. We're going to move to cleaning up, which means we're going to walk out of this and I'm going to help you get a copy of everything that you've done on your home computer, and then we'll be done. But we see we have some questions before we move on. So Vladimir, you had your hand up.
I was just wondering, can we create, I don't know, multiple like nano scripts and then
Yes.
interact with, so I kind of generalize this script, but then I use another script that I created to kind of, I don't know, make more complex.
Yeah, absolutely. You can totally make copies of these.
Okay.
Yeah, and you can see how you can do that on the way out. You open it up in Nano, and then as you're coming out, it asks you for what file name. Really easy there to just say 0.2 or whatever, right? So those changes will be saved to a new file. So you could build it that way. We can just write a whole new one. Absolutely, absolutely. Other questions that people might have? We're having a capital convention fight in the chat here. I'll let Chris and Camille sort that out. Let's just leave it as they're strongly recommended. It will make your life a lot better. Any other questions about what you've seen so far as we move to wrap up? I think we got about 10 minutes left. Go once, go twice. Okay. So we are going to want to save the stuff that we did in this SRR file, and we want to save the other content as well. And so how will we do that? Well, we're going to want to, well, what did we do at the beginning? Well, we're going to do the reverse of what we did at the beginning, right? So we got a file from somewhere else, and then what do we do to it? We'd expand it, right? We had to break it apart. We had to unzip it, right? We had to untar it. So we're going to do the reverse of that. So we're going to go back to the original directory where we started. And from there, we are then going to ball this all up together. We're going to zip it up. And we're going to then move back to our home computer, and we're going to reach in and we're going to grab that content from the remote server and stick it on your home computer. So that's what we're going to do. It's going to take us about 10 minutes and then we're done. And you'll have seen kind of everything that you would do if you were interacting on a remote system. Yes, there's a bunch of commands that are going to be covered later that are very specific to using the queues and getting access to a lot of processors and so on. But the administrative kind of grunt work, you'll have seen at least the beginning of each of the steps for that. So that's what we're going to do. So we need to go back. We know how to change directories and go up, but we don't know how to change directories and go back. So let's figure out how to do, let me show you how to do that first. So I'm going to just go clear here. And our command for seeing the contents of the current directory is ls. but there's a flag you haven't seen yet. And it's often referred to as the all flag, and it's -A. And so if I run this, what do you see? What's different here? What's new? The dots, that's right. So these are the beginning of hidden directories on Unix, Linux systems. Files and folders that are special are often hidden, and we hide them by putting a dot in front of them. There are two special files. Everything on the systems is a file. Even a folder is a special kind of file, but we'll set that aside. There are two special files inside each directory. One of them is the dot, and the other is the double dot. You've already seen the dot. When we go dot/demo.sh, that dot means here. It is the file that is the self-referential one. It points back to this directory. And you can see why that might be useful. Well, you see exactly how it is useful in saying, no, I really want you to look here. I know your convention is to take that first thing and go look someplace else, but I want you to look here. I mean this file. The dot means the parent of. So the dot is itself, and the dot, you can imagine the dots being strung out in a line. Each dot before is the parent of. So this is me, this is my parent. That's what those two files mean. One of them points here. Where does the single one points here? Where does the double one point?
Like more directories?
Not
like
the home. It will point to a different directory. It points to the parent directory. Does anybody remember what the parent directory's name is? Does anybody know how we'd find that out? What's the command to see where we are? Right. So you're right, Pablo. That's a directory. But if we had forgotten that, what's the command to see where we are in the file structure?
Where I am?
Yes. Not where am I?
Oh.
Yeah, PWD.
Oh.
There we go. Yeah. Tricked you before. It's PWD, print working directory, right? I don't know why I typed it in the chat window. Won't do anything there. It's PWD. So I can see I'm in /home/user09/extract/fastq, right? So fastq is the directory I'm currently in. Extract is the parent. So dot points to fastq, dot points to extract, right? So if I want to change directory to the parent, well, one thing I could do is I could type out the whole address from the beginning. So /home/user09/extract. That would take me their directory. That's called the absolute address. But relative to where I am right now, what do I type in to say go to my parent? Yeah, there we go. 2 dots, right? CD dot. Okay. So CD dot will take me to extract, and you can see that here, right? This has changed. Right? My prompt has changed. And if my prompt, I was on a different system and the default didn't do that for the prompt, I could do print working directory, and I could check that. Right? If I want to go to the very root directory, I can go CD, and remember I told you there was a folder called root, and that's what that first slash meant. I go CD // and now I'm at the very base of the whole system. And if I do an ls here, there's a whole bunch of stuff. I don't know what it is. Well, now I have a bit of a problem. How do I get home? Right? How do I get back to, I'd have to remember it. I have to remember it's /home/user, and you might forget that from time to time. Does anybody remember the character that was there? Yeah, there it is. It's the tilde. The tilde represents home. So I could type CD tilde, and it will take me back to my home. See, the only difference here is the difference between the slash and the tilde. So if I go print working directory, You can see I've gone home/user. I'm going to go back one last time to the root directory, and I'm just going to type cd. There's another shortcut that they have built in, and that is if you just type change directory and don't tell it where you want to change the directory to, Ruby slippers, it just brings you home. There's no place like it, right? So you can see the tilde has come back here as well. And if I do a print working directory, there we are. So 2 last steps, right? We need to wrap this up. We need to pull together the content that we've been working with, and then we need to pull it down on our home system. So we're going to ls. So everything is in the extract directory, okay? So we are going to tar, right? And instead of extracting, right, we're going to combine up. We want it verbose, we want it to tell us what it's doing, and we want to tell it the file name or the list of file names. And so we're going to ask it to tar up the extract file, right? The folder. Everything that's in there, it's going to take it and it's going to bind it up. Refusing to create an empty, oh, my mistake. I forgot to tell it the name of the file that we want to use, right? So we want to create a thing called my stuff. Quick second here. Yeah, so we want to create, let's create a folder called shell demo, right? .tar. Okay, so that's the file that we're going to bind everything into. And what do we want to put in it? The extract directory. So that's the format here. We're going to use the tar command, right? We're going to do this combining. We're going to do it verbosely. So it's going to tell us what it's doing as it's doing it. And we're going to pass the file name that we want to use. And so we're going to make up one here called shelldemo.tar. And we're going to use the extract folder. So that's what we're running here. I'm going to press enter. Right. And we can see it went through, and because we used the -v command, it told us every single file that's in there. Right. If I do an ls, I can see that we have demo.tar. I can do a zip with it, gzip shell demo.tar, and I'm typing so fast because I'm using tab completion there. Gzip space shell demo.tar. Right, and it'll go about ls. Right. Now you see it's got that gzip at the end, right? So it's been bound together and compressed. So everything that you did today was done in that directory. It's all been compressed together. And now we just want to get it on your machine. So that's the very last thing we're going to do. So does anybody remember the command for getting out of here? For leaving this shell and getting back to our home shell? And the home shell being the one on your machine? It's exit, that's right. So that was a command I don't think I pointed out directly, but you saw me use it when I had to move out, right? So exit gets you out. And notice that it tells you it logged out, the connection is closed, and it puts you back on the prompt that you should recognize as your home prompt. So fingers crossed, there's one last command for us to do here. SSH is secure shell. That opened the connection, the encrypted connection that we were using with this remote server to do this work. Can people hear me right now? Sorry, my phone's ringing, it's taken over the, okay, you can hear me still, thank you. So SCP is secure copy. So we are going to pass a very similar set of information, but we want to grab a file and bring it back. So it's going to look very much the same as SSH. So SCP and then user 09, right? This is our name on the system, right? At the location of the system, right? And so it's training dot u of a dot c3 dot ca, right? So that's going to get us into the system. From there, we need to tell it where we want it to go and what we want it to get. We signal that with a colon. Now, we've been very clever here and put what we need, what we absolutely want, in our home directory, because that's where the default login point is. If you put it someplace else, you'd have to put a path reference here. We're going to ignore all that because we can just ask it for shell demo.tar.gz. Right. Last thing you're going to need to do is put a space in and a dot, because you're going to copy it and you need to say what you're copying and where you're going to copy it to. Right? So we want it to show up here. So I'm going to, this is a long thing. This is one I'm going to copy and paste into the Etherpad. I'm assuming it's right. If it's not, I'll correct it in Etherpad in a moment. And I'm going to put it here just below the wget command. Now, remember, you can use this. You'll get mine because they should basically be the same, but you probably want to change the user number. So you're actually getting your content in case you did something different. And so I'm going to run this. It's going to ask me for a password. That's a good sign. It's the same password as you typed in for SSH. So it's bigfoot.369. Right. And it will go up there and you can see it start giving you the countdown as it gets it. And if I do an ls here, right, you're going to see a whole lot of stuff in my local home directory. But what you want to see, where is it? There it is. Sorry, it's at the very, very bottom. I'm looking in the middle. So there it is, and that's where you should all be. And you should be able to unzip it and so on and so forth. Now, if you're on some of the other operating systems, it might be different for you to unzip versus tar, depending on what they have. But thanks very much. You've come a long way today. This was recorded. Our intent is to make it available. In the Etherpad, again, at the top, item number 5 is a location for kind of a walkthrough for something very similar to what we've done today, but certainly not identical. So you have that. So I'm available for the next little while if you have some questions. Otherwise, thanks very much. If you're coming on for any of the other sessions, those information for those is on the Bootcamp page. We probably found out about this. The one that feeds in directly from this is the HPC Essentials, and Camille's leading that. And I see that he's unmuted, so he might want to tell you something special about that.
So basically, we're going to use the skills that you've learned in this course in order to actually start using the clusters and high-performance computing. So that's going to happen on Thursday.
Yeah. So, and did you want to say just a little bit about what the use of clusters means? Just if there's people here who weren't sure about it. And
Oh, okay. So basically, right now, you've learned how to use a remote computer. Now, Compute Canada has clusters, which is basically a whole bunch of computers that are used for calculations by researchers. And in order to use more than just one computer, there's tools and practices that you need to do that. So that's what we're going to go over on Thursday, basically. Right now, you've learned how to use one computer, and now we're going to teach you how to use thousands, essentially, in order to get all your work done.
So if that's attractive, sorry, go on.
Yeah, and then following up on the Tuesday after that, we'll talk a little bit about parallel programming, and then the Thursday, 9 days from now, we'll talk about debugging and seeing what happens when there's a failure and how you should work around that, and basically the practice of actually using those computers. So those are the following courses within this series.
And they have the HPC at the front of them. So I believe there's still space for them, but even if there isn't, you should still sign up if you're interested, because as you're seeing today, we had 33, 34 registrants, and we certainly didn't have that many attendees. We can expect that to happen for the future as well. People have good intentions. They don't always follow through. If you're interested, we'd love to have you come along. So thanks very much. Log out as you see fit, and we'll wait around here until most of you have disappeared. So if you have questions, feel free to throw them in the chat, or we'll talk them out. Thanks. Question about how long will this stuff be available to download? We'll have this stuff available probably for until the end of the HPC, that series. So it'll be available probably for the next week. It's possible that it'll be done. We're not shutting it down tonight. You leave it open now, it'll download for you without difficulty within the next hour. So the cluster will still be here for that. And with that in mind, if you do want to come in and practice some things here, so later tonight or tomorrow, you wanted to come in and you wanted to try just moving around directories again, if that's something that's new for you, or you wanted to try and play around with the shell script or make a copy of it and play around with, you're welcome to do so. They're here for your training. They will disappear next week though. Yeah, that was Pablo writing all the notes. Thanks very much. It's a nice, useful resource for lots of people, particularly the parenthetical summaries in there. So if you haven't looked at the Etherpad for a while, you should have a glance in there. There's been a lot of collaborative work, so thank you. Actually, I promised you something and I didn't put it in there. And then there's a full copy of my script. I imagine it's fairly identical to yours, but in case it's not, that's the last thing I'll do. So at the bottom of the Etherpad, the final script. So everything's in there now.
So there's a question. I'm using SCP. Can I open another terminal and log in with SSH at the same time? And the answer is yes. In fact, we saw examples of that because there was multiple people logged in using user 01 on the same machine.
Yeah, it's a really powerful feature. It can get you into trouble sometimes if you forget. So we have a question here from Cerise about SCP and, no, Pablo, about the zip file, sorry. What operating system are you using, Pablo?
Windows 10.
Windows 10. So depending on the environment that's in that space, if you're in like the Ubuntu environment that Vladimir moved into, it should work. If you're in PowerShell, I'm not certain about that, but the command for the system we were logged into earlier today, tar I'll type in here for you, dash xvf. It would be shell demo.sh. Should be something like that.
Also, the what's it called, zip is actually different from Windows zip. There's actually multiple different archiving programs, and the zip that we were compressing stuff was with GNU zip, as opposed to the regular Windows zip program.
Once you're back in your home space, unless you're really feeling you want to be in the command line, feel free to use whatever extraction tool you might, or archiving tool you might normally use, right? So you should be able to move outside of the shell environment, go to Windows File Manager, find it. If you already have an unzipping tool that's, you know, graphic user interface, point and click kind of thing, you should be able to use that on these files. Oh, sorry, not shelldemo.sh, because shelldemo.sh is not the zip file. Yeah, if you just have the tar file, because it's not zipped, your extraction tool should still be able to handle it. But again, it's a question of the operating system and what tools are installed on it. It's one of the reasons we moved very quickly to being on the remote system, because there everybody's the same. So, thanks, Chris. Appreciate your help. So, thank you, Pablo. Any last call? Anybody else? Going once, going twice. Okay, seeing nothing but people saying that things are pretty much good for them. So thanks very much. The Etherpad will remain available as well. It'll be available much longer, but at some point they do clean them out. So if you come back in a year, it's not there, sorry. But it should be there next week or a month or two from now as well. So thanks very much. Take care, and we'll see you at some future sessions.